starting the session in 1 minute. Okay. Good afternoon, everyone. My name is Satyam Kamatap Singh, and I am PhD scholar at IIT Bombay. And this I am also the TA of your course, that is Smart Grid Basic to Advanced Technology, whose instructors are Professor N.P. Badi sir and Professor Premlata Janana. And this is the 7th tutorial session. Further moving to the first topic, that is the importance of DC distribution systems. There are various advantages because we have two kinds of grids, mainly that is the AC and DC based grid system, and there are various advantages of AC also and the DC also, and we will discuss in the further slides. And from which point we have this DC is more economical as compared to AC. So coming to this importance of the DC part, there are five, generally I have depicted that five most important importances of the DC distribution system. That if you see that various congestion states such as like AC to DC or DC to AC can be avoided by forming DC grid, and overall efficiency can be improved. That is actually the basic principle, that there are several devices which generate DC power, and certain more complicated devices which generate AC power. DC power generating sources such as solar PV, battery storage systems, BS systems are there, and the AC power generating systems such as your synchronous generator and your wind systems. So these are the two different types of power generating sources. So if for the distributing it to a large distances, so we prefer mainly AC, and at a very high distance such as the greater than 600 kilometer, we prefer DC also. As you can see from this graph, right side curve, that this is the investment cost versus transmission distance curve is I have depicted. If you see here, this is the red one curve is the HVDC total cost, and blue line is the AC total cost. If you see this both lines, if you plot with respect to distance, the initial cost of this HVDC total cost HVDC distribution system is very high as compared to the AC, because you need power electronic converter interface and various filters also, AC filters also in the previous section, and the large amount of reactive power support is also needed. So the initial cost related to HVDC system is very high. As compared to this, if the initial cost you see for the HVAC system, it is lower as compared to this. And after plotting this graph, if you see that at a 600, nearly at 600 kilometers, this both costs should become equal. If you see, and this cost, if you further increase the distance, then the curve of the HVDC total cost is lower as compared to the AC. So for the longer distances, optimally greater than 600 kilometers, we prefer HVDC because it is now more economical as compared to the AC, which is being seen from the AC, this cost versus distance curve. And also you can see that the transfer of this high power system, that is above 765 kV line, DC is more economical as compared to AC. Coming to the second advantage, that is a no problem of reactive power harmonics or the frequency control. Because if you see the DC, this is the current. If you see plot this, it will come with respect to time is at a constant. But if you see same with the AC, it have certain alternating nature which vary over time. So if you see that this current is constant in the DC part, so frequency is zero because there is no alternating term. And if you see this AC term, this is the normally which we use that 50 cycles per second, that is 50 hertz frequency. So these two kinds of systems are there. So there is a control is needed for the frequencies. So there is a control is needed for this controlling this frequency and the harmonics and the reactive power. Coming to this third part, that is the synchronization issues and the controlling become easier. So if you see the DC part, so the frequency, there is no concept of frequency here in the DC. So the synchronization between the different DC systems become very easy because you don't have to synchronize, only you have to consider check the voltage and the angle. Voltage and angle. So coming to the fourth advantage, that is eddy current hysteresis loss and the skin effect. If you see also that this eddy current losses, it is also a function of frequency, and this hysteresis loss is also a function of frequency. So if the frequency increases, this eddy current losses and hysteresis losses also increase. So these two factors is also is not present in the DC because there is no concept of frequency. Frequency is zero. So the eddy current losses and the hysteresis losses are zero, and the same with the skin effect also. And coming to the fifth part, that is the reducing the stress on the conventional grid and congestion of the this transmission line. Suppose you have a one transmission line, and this is a rated value of this current which can flow is of 50 amps. So suppose you connected some load at the end point of view, and you have a source at this point. So if you see this suppose this generating source have an infinite inertia, and it can generate any amount of power which is there. Suppose I am increasing this load, which consumes, suppose the power is I square R, and this power became greater than such that the current hits the limit, current went greater than 50. So the limit inside of this heating problem will occur inside of this wire, and this wire is not capable of drawing carrying this current greater than 50 amps. So this type of problem inherently experienced in the AC distribution system, which is not possible and which cannot be seen in the DC distribution system, because if you see the DC distribution system, this kind of system is there. So this is grounded, and this is V1 and V2, and this is X. So if you transfer the power and you have a certain angle at delta and V2 at angle 0 degree, this X term, X is actually not a, here I have not represented this as a inductive term because XL is L omega, that is 2 pi L. So there is no concept of frequency inside, but there is a parasitic, some kind of inductance inside of the system. So power is generally V2, V1, V2 by X sine delta. Same with the reactive power supply. This reduction, this stress on the conventional grid is further reduced when we use this DC distribution system as compared to DC. So there are three types of HVDC, this DC distribution system, that is HVDC, NVDC and LVDC, based upon the voltage level. If you see the first, that is HVDC, the voltage range is greater than 500 kV. Based upon that, we said that this is a HVDC system, and it is economical and efficient over AC at a long distance, as you have seen. Devendra, please. Okay, thank you.
this is
So
economical if you
this
go
is
greater
economical
than
if you
600
go greater
kilometers.
than
Same
600
with the
kilometers.
MVDC, mega
Same with the
voltage distribution
MVDC, mega
system. If you
voltage
go
distribution system.
operating
If you
at a
go
11 kV or
operating at
33
a
kV
11 kV
system,
or
that is
33
the
kV
mega
system, that
voltage
is the mega
system.
voltage
If you come with the
distribution
lower
system.
level,
If
that
you
is
come with the
LVDC
lower
system,
level, that is
that
LVDC
is of
system,
voltage level
that
48,
is of voltage level 48 volt, which
household
we
level, that
experience at a household level,
380
that
volt, 230 volt,
380 volt,
600 volt
230
kind of
volt,
system is the
600
LV
volt kind
distribution
of system is the LV
system.
distribution
48
system.
volt you generally see with
48
the
volt
battery
you
bank,
generally see with the
that is
battery
the
banks,
12 volt,
that is
48
the
volt,
12 volt,
36 volt
48
kind of
volt,
system
36
you
volt kind of
generally
system
experience with the
you
battery system.
generally experience with the battery
So
system.
this is the one question
So this is the one question
I want you all to
I
solve.
want you all to solve.
I'm giving you
I'm
2-3
giving
minutes
you
to solve this
two
question.
three minutes to solve this question.
Go through this question and
Go through this
write the
question
answer in
and
the chat box.
write the answer in the chat box.
If you have any doubt, you can open
If
your
you have
mic
any
and ask
doubt,
me.
you can open your mic and ask me.
Any answers, Amit,
Any
Devendra?
answers, Amit, Devendra?
First one is true,
Okay.
and
Okay.
Amit, write in the chat box.
Amit, write in the chat box if
There is a external noises there.
there is a external noises.
First is true. Okay.
First is true.
First is true according
Okay.
to
First is true according to Amit.
You have 1 more minute to solve.
You have 1 more minute to solve, if anyone.
Okay, let me solve this
Okay,
question.
let me solve this
Suppose
question.
before moving to this
Before
answer
moving
part,
to this
let me
answer
explain
part,
this skin effect.
let me explain this skin effect.
Suppose this is a conductor
Suppose this is
and
a
you
conductor
wanted this current to
and
pass
you
through it.
wanted this current to pass through it.
So before moving to this,
So
so you wanted
before moving to
this
this, so
can
you
flow
wanted
through
this
this whole
can
area,
flow
whole
through
area of
the
this.
whole area
But
of
what
this.
happens that due to
But
this
what happens that
frequency, the
due to
higher
this
frequencies,
the higher
this
frequencies
alternating nature,
component, this
what
alternating
happened
nature,
that the whole
this
area
what
is not
happened that
covered,
the
that
whole area is not
this
covered,
current
that
flows to a
this
certain
current
depth,
flows to a certain
and below
depth,
certain depth it
and
is not
below
possible the
certain
current
depth
to flow.
it
So the
is not
current flow
possible
to
the
this
current to
through
flow,
the
so the
surface,
current flow to
not the
this
inside.
through the surface,
So
not the
this
inside.
current density inside of this
So this current
conductor
density
represented
inside
by
of this
this J is equal
conductor
to Js
represented by this
e
J
to the
is equal
power
to
minus
Js
x by
e to the
delta.
power minus
This
x by
x is
delta.
the penetration depth.
This x is the
Penetration depth in
penetration
such
depth.
that the
Penetration
how
depth
much
in such
current
that
should go
the
inside
how
of
much
this.
current
Suppose this
should
is the
go inside
center
of
of this
this. Suppose this is the
conductor.
center of this
So how much
conductor.
depth from the
So
surface
how
it
much
can
depth
move
from the
towards
surface
this
it
center.
can move
So
towards
this is the
this
screen
center.
depth this
So
d,
this is the screen depth
at which
D
this
at
conductor
which
is moving.
this
and
this
this
conductor is moving,
delta delta
and
is the
this
actual skin depth
delta is
which
the
depend
actual
upon the
skin depth
resistivity,
which depend upon the
frequency,
resistivity,
permeability. Okay,
frequency,
relative
permeability. Okay,
permeability. So
relative
based upon that,
permeability.
you have a one
So
factor
based
that
upon
up
that,
to
you have a
this
one
point
factor that
it
up
can
to
move
this point
where
it
the
can
this
move
current
where
density
the
is
this
having certain
current
factor.
density
Suppose
is
J
having
is
certain factor.
x is
Suppose
equal to
J
delta.
is x is
So
equal
this
to
Js
delta.
by E. So
So this
maximum it can
Js by
go
E.
at
So
J equal
maximum
to
it
Js
can
by
go
current
at J
density
is
you
equal
can
to
get.
Js by
But
current
you
density you
cannot
can
get
get.
that
But
if
you
x is
cannot get
infinite.
that
If you
if
see
x is
this
infinite.
Ex is
If you see
infinite,
this
what will
E
happen?
x is infinite,
E
what
to the
will
power
happen?
minus x by delta.
E to the power
X by
minus x by
delta
delta,
is there.
x
X
by
is infinite.
delta is there,
So
x
1
is
upon E
infinite.
infinite will
So
be
1 upon E
this
infinite will be
E infinite.
this
So this will
E
become 0.
infinite, so this
So
will
this is
become
the
0.
factor such that you
So this
cannot
is the
go
factor
a
such that
from
you
a
cannot go
certain limit,
a from
which
a
is the
certain
delta. So
limit,
you will
which
get
is the
certain
delta. So
percentage of
you will get
current
certain
density, not
percentage
below
of
that.
current density,
So
not
and
below
also
that.
this current
So
this
and
skin depth
also
is
this
also
current
dependent
this
upon
skin
certain
depth is
factors
also
such as
dependent upon
what
certain
resistivity
factors
of
such
your
as the
conductor
what
is there, what
resistivity of your
frequency you are
conductor is there,
operating, and
what
what is the
frequency you
relative
are operating,
permeability.
and what is the
So
relative
coming to this
permeability.
question, as
So
reading
coming to
from the
this
question in
question,
this
as
first part,
reading from the
it is
question,
saying
this
that the
first part,
skin effect
it is
refers
saying
to the
that the skin
tendency of
effect
the
refers
alternating
to the
current
tendency
to
of the
flow
alternating current
predominantly
to
near the
flow
outer surface of the
predominantly
conductor.
near the
As you could
outer
see
surface of
from
the
the right
conductor.
side
As you
image
could
also,
see from
the
the right side image also, the
if you have a DC current is
DC,
there,
if you have a
so there is a
DC
no
current is
concept
there,
of this
so there
skin
is a
effect,
no
because
concept
why
of
delta
this
is there,
skin
delta
effect,
is
because
also
why
a
delta is
frequency
there, delta
dependent
is
term.
also a
If you see
frequency
from this
dependent term.
equation also,
If
the
you see
frequency
from this
dependent.
equation also,
So
the
delta,
frequency
if you
dependent.
see
So delta,
frequency is
if you
0,
see
frequency is 0,
frequency is
suppose the
0,
x term is 0.
frequency is 0,
So
suppose the
delta
x
will
term is
become
there.
certain kind
So
of
delta
infinity
will
factor.
become certain kind of
So that
infinity
kind of
factor.
system is there,
So that kind
which
of
you
system is there,
have the
which
effective area.
you
The
have the
R
effective
effective
area.
is
The R
overall R.
effective is
But in
overall
the case
R.
of AC system,
But in the case of
AC current system,
current
this
system,
R effective is lower as
this
compared
R
to this
effective
R.
is
That
lower
is a
as
less
compared
than
to
this R.
this R.
So
That is a
that's why
less than this R. So
this current flows through the surface.
this
And
current
if
flows
you
through the
increase the further
surface.
the high
And if
frequency
you
system,
increase the further the
further
high
you can
frequency
see that
system,
the
further you can
depth
see
it
that
can penetrate
the
is further
depth
become
it
lower.
can penetrate is further
So
become
same
lower.
with there, that the current
So same
flows
with
to
there,
the surface.
that
So
current
this is
flows to
true.
the surface. So
Coming to the
this is
second part,
true.
that skin
Coming to
effect
the
becomes
second
more
part, that
prominent
skin
at a
effect
lower
becomes more
frequency and
prominent at a
causing
lower
increased
frequency
resistance in
and
the
causing
inner areas
increased
of the
resistance in
conductor.
the inner
Actually,
areas
if you
of the
see
conductor.
from
Actually, if
the
you
figure
see
also, the high
from
frequency
the
system
figure
has a
also, the
higher
high
effect of
frequency
this
system
skin
has a
effect.
higher effect of
But
this skin
at a
effect.
lower frequency,
But
there is
at
a
a lower
less
frequencies, there
effect of
is a
this.
less
And in the
effect
DC
of this.
system,
And
also there
in the
is a no
DC
skin effect.
system, also
So
there is
this
a
is
no
false,
skin effect.
because at
So
the
this
lower
is false
frequency,
because at the
there is
lower
a
frequency,
not much
there is a
increase. This
not much
prominent, not
increase.
more
This
prominent.
prominent, not more
So coming
prominent.
to this third part, that
So
skin
coming to
effect
this
has
third part,
significant
that skin
implication in the
effect
high
has
frequency
significant
applications such
implication
as
in the
radio
high
frequency
frequency
transmission and
applications
the
such
power
as radio
distribution and
frequency
microwave
transmission and the
frequency.
power
The
distribution and
microwave
microwave
frequency is
frequency.
very high.
The
So
microwave frequency is
where
very high.
skin effect
So
is more prominent.
the
So
skin effect is
as
more
you can see
prominent.
from the figure
So
also.
as you can see from
Coming
the
to the
figure
fourth
also.
part, that one way
Coming
to
to the
mitigate
fourth
this
part,
skin
that one
effect
way
is
to
by
mitigate
using
this skin
stranded
effect is
conductor
by
instead of
using a
solid
stranded
conductor,
conductor
which
instead
increases
of
the
solid
effective area.
conductor,
That is
which
actually
increases the
true,
effective area. That
because
is
if
actually
you
true,
use this
because
stranded
if
conductor
you
instead
use
of
this
using one
stranded
single
conductor
conductor,
instead of
if you
using
use
one
this
single conductor, if you
stranded
use this
conductors,
stranded
then this
conductor,
cross-sectional area,
then
if you
this
see from the
cross-sectional area,
cross-sectional
if
area,
you
got
see from the
increased.
cross-sectional
Initially,
area
you are
got
using
increased.
this surface
Initially,
area.
you are using this
Now
surface
you
area.
have a, if
This
you are using
now
the
you have a,
strands
if you are
of the
using
four
the
single
strands
conductor with the
of
four
the
strands,
single conductor with
then
the four
you can
strand,
increase this
then
cross-sectional
you can
surface area
increase
and
this
the current will
cross-sectional
also
surface
increase
area
further
and the current will
based
also
upon that.
increase further
So
based upon
this
that.
is also
So
true.
this is also true.
Coming to this
Coming to
most
this
important topic, that is the
most
DC
important
microgrid
topic, that is
topologies,
the
and
DC
which is
microgrid
also important
topologies,
for
and
your
which is also important
assignments
for
also,
your
solving the
assignments also,
assignment
solving
problems.
your
So
assignment
coming to
problems.
this first
So coming
topology
to
of the
this
DC
first
microgrid
topology
topology,
of the
first is
DC
the single
microgrid
bus
topology,
topology.
first is
Single
the
bus in the
single
sense
bus
कि one
topology.
have
Single
this
bus in the
carrying
sense
current
कि
in
one
the
have this
and
carrying
one
current
having
in
this
the
return
and one
current.
having this return
So
current.
because you
Current.
need a close path
So
to
because
current to
you
flow.
need a close path
So
to
if you
current to
see
flow.
from the right side figure
So if
also,
you
there
see
is a
from the
red
right
line
side
is
figure
there.
also, there is a
Red
red
line is
line
there.
is there.
If you see,
Red line
consider
is
it as
there.
a
If
live
you
wire,
see, consider
and you
it as
have
a
a
live
black
wire,
wire. If you
and you
consider
have
it
a
as
black
a
wire,
neutral.
if you
So
consider is
live
at a
wire the
neutral.
current will
So
flow,
live
and
wire
the
the
neutral
current
wire
will
it
flow,
will return.
and the neutral wire
So
it will
if you
return.
connect, if you see
So
from the
if you
here that
connect,
load is
if you
also
see from
connected,
the here that
utility is
load is
also
also
connected,
connected,
this
utility
fuel
is
cell
also
is also
connected,
connected,
this
PV
fuel cell is
panel,
also
wind turbine,
connected,
and
PV
battery.
panel, wind
All are
turbine,
connected
and
to a
battery.
single
All
bus.
are connected to a single
But the
bus.
problem with this single bus is
But the
such that
problem with
if
this
there is
single
a
bus is
fault,
such that
if
if there is
suppose
a
there is a
fault,
fault
if
at
they suppose there is a
some,
fault
let's say at a
at
PV turbine,
some, let's
so
at a
what will
PV
happen?
turbine.
It will
So
draw
what will
the
happen?
power
It
will be
will
taken from
draw,
the
the
battery
power
also
will be
to this
taken from
point
the
of the
battery
fault,
also
and
to
the
this
wind
point
also
of the
supply
fault,
the fault.
and the
This
wind also
PV also
supply the
supply
fault.
the fault.
This
This
PV
fuel
also
cell also
supply the
supply the
fault.
fault.
This
So
fuel cell also
you need
supply
a
the fault.
certain
So
topology such
you
that
need
you
a
can
certain
disconnect.
topology such
If
that
you
you can
connect this DC
disconnect.
bus bar at
If
a
you
certain
connect this
point,
DC bus bar at a certain
you
point,
will disconnect this system, the
you will
whole system,
disconnect this
the power
system,
supply,
the
whole
whole
power
system,
supply
the
will
power
get
supply,
interrupted.
whole power
So
supply
as
will get
I guess
interrupted.
it is
So
also
as
written here that
it
it is
it is
suitable
also
for the
written
low
here that
voltage
it is
application,
suitable for the low
and
voltage application,
at low
and
voltage you can boost the
at low
voltage
voltage you
to
can
at the
boost
desired
the
level
voltage
which
to
you
at the
want to
desired
supply.
level
Suppose you
which
wanted to
you want
supply
to
at a
supply. Suppose you
450
wanted
or
to supply
600
at a
volt,
450 or
you have to
600
use
volt,
this
so
DC to
you have to
DC
use
boost
this
converter for
DC to
that
DC
purpose.
boost
Okay.
converter for that purpose. Okay.
So this ESS, that
So this
energy
ESS,
storage
that
system, which is
energy storage
with the
system, which
converter is
is
more flexible and
with the
control, which
converter is
I have
more
also
flexible
shown you
and
that
control, which
40
I have
volt to
also shown you
450 or
that
600 you
40
can
volt to
directly
450 or
feed
600 you
from
can
this
directly feed
topology.
from this
And you also have the
topology.
bipolar
And
single
you also have
regulated
the
bus structure.
bipolar single
Same with this
regulated bus
because one
structure.
have a
Same with
return
this because
positive
one
current
have a
direction, one
return
has a negative
positive
current
current
direction
direction,
to
one has
return.
a negative current
So
direction
this
to
is a
return.
single
So
bipolar,
this is a single
because you have a
bipolar,
positive negative.
bipolar because you have a
Bipolar is there,
positive
but is
negative.
a single
Bipolar is
regulated
there,
bus
but is a
structure. Only
single
single bus
regulator
is there.
bus structure. Only single bus is
So
there.
reliability is improved,
So
but the
reliability is
problem is such
improved,
that
but
if the
the
fault
problem is
occurs
such
at a
that
one point,
if
that
the
it
fault
get
occurs at a
propagated.
one point, that
So
it
coming
get
to this
propagated.
second, that is a
So coming
multi-bus
to this
topology.
second,
If
that
you
is a
see that
multi-bus
this is the
topology. If you
main
see
bus at
that
a
this is a
380
main bus,
voltage
main
level,
bus at a
which is
380 voltage
connected
level,
through DC to AC
which is
converter,
connected
DC
through
to AC
DC to AC
converter to
converter,
the
DC to AC
grid,
converter to
this
the this
utility grid.
grid,
And if
this
you see
utility
that there
grid.
are certain
And
buses,
if you
bus
see
1,
that there
bus
is
2,
certain
bus
buses,
n.
bus 1, bus
So
2,
each
bus
bus
n.
is connected to
So
some
each
kind
bus
of
is connected to some kind
distributed
of
generators, and
distributed
others is also
generators,
connected. So
and
this
other is
bus,
also
suppose
connected.
this is
So
the bus
this
2,
bus, suppose
bus
this is
2
the
is
bus
fully
2,
isolated with the
bus
bus
2
1.
is fully isolated
Suppose
with
there
the
is a
bus 1.
fault in the bus 1.
Suppose there is a
So
fault
you
in the
can
bus 1.
disconnect
So
through the
you can
point this
disconnect
using
through the
circuit
point
breaker this
this
bus 1, so
using
that this
circuit breaker
fault
this
should not
bus 1, so
propagate to
that this
bus 2
fault should
structure.
not propagate
So
to
this
bus
is the
2
main
structure.
point of this
So
advantage
this
of the
is the main
multi-bus
point of
system.
this advantage of the
And
multi-bus system.
this also you can
And
say that
this
every
also you can
microgrid is
see that
able to
every
absorb,
microgrid
inject
is
power
able
from
to
its neighbor
absorb,
in case
inject
of
power
shortage or
from its
surplus.
neighbor in case of
Some
shortage or
corrupted buses
surplus.
can be
Some corrupted
automatically
buses can be
isolated.
automatically
That is the
isolated,
main point, because
isolated. That is the
the
main
bus
point,
bar it
because
is have to
the bus
maintain
bar
this
it is
voltage at
have
380
to
voltage,
maintain this
because
voltage
from
at
here
380
you
voltage,
should
because
have to
from
give this
here
power
you
to
should
this
have
grid.
to give this
So the
power to this
inverter which
grid.
you have
So the
used for the
inverter
DC
which
to
you
AC
have
conversion,
used for the
that
DC
have
to AC
certain
conversion,
specified
that
limits
have
such that
certain
it have
specified
maintained this
limits such that
380
it
volt.
have
It should
maintained this
convert
380
to
volt. It should
230
convert to
volt or line to line. If
230
you want
volt or
314
line
volt,
to line.
you
If
want
you
to
want 314
convert.
volt, you want to
And this bus one
convert.
is also can
And this
supply the
bus
power
one is
to bus
also
2
can
load.
supply the power
Suppose
to
this is a
bus 2
DC load
load.
at bus 1,
Suppose this
this
is
is
a
DC
DC
load
load
at
at
bus
bus
2.
1, this
This
is DC
DC
load
load
at
at
bus 2.
1
This
can
DC
get
load
supply
at
from
1
the DC bus
can get
2
supply from the
generating
DC
source
bus
also.
2
This is most
generating
important.
source also. This is
And
most
you
important.
also see that this
And
solid state
you also see
transformer
that this
enable
solid
DC
state
microgrid
transformer
energy
enabled
management
DC
in lower
microgrid
voltage
energy
level will be
management
in
in
the
lower voltage level
SST
will
domain,
be
that
in
is the
the
solid state
SST
transformer. That
domain,
is
that is
also
the
an
solid
important
state
point.
transformer. That is also an
Coming to
important
this
point.
other topologies,
Coming to this
if you
other
see this
topologies,
other
if you see
topology, this
this this
the
other
reconfigurable
topology, this is the
topology.
reconfigurable
Reconfigurable in the
topology.
in the sense that
Reconfigurable
if you
in the
have a
sense that
certain
if
topology
you
you
have a
have already
certain
configured,
topology you have
but
already
you want to
configured,
change it. So
but
how
you
you
want to
will do?
change it. So
Can
how
you
you
do
will
in
do?
the
Can you do
this
in the
multibus topology?
this
You cannot do.
multibus
You cannot do.
topology?
Why?
You cannot do.
You
You
cannot
cannot
connect
do.
bus
Why?
two
You
generating
cannot
sources
connect
as
bus
bus 1,
to generating
because bus
sources
1
as
has
bus 1,
certain
because bus 1
specified
has
limits,
certain
but that is
specified
possible in
limits.
the
But that is
reconfigurable
possible in
topology,
the
if which
reconfigurable
you can see this.
topologies.
This is the
If
radial
which you can see
topology
this,
left
this
side,
is the radial
and right side is the
topology left side,
multi-terminal
and right side
topology.
is the
So
multi-terminal
if you see
topology.
from the radial
So
topology
if
is
you
such
see
that
from the radial
the
topology is
power
such
flows
that
from the lower
the power
portion to the
flows
higher
from
portion,
the lower
only
portion to
one
the
way.
higher portion.
Same with
only
this
one
left
way.
side, that
Same
radial,
with this left
the
side, that
lower
radial,
portion to upper
the
portion.
lower
And
portion to
also
upper
you can
portion.
take this power
And
through
also
the
you
DC
can
bus
take
bar
this
to
power
DC load,
through
or
the
you
DC
can
bus bar to
generate
DC load,
this
or you
PV
can generate
generating
this
sources
PV
and transfer this
generating
power to this
sources
DC
and
load.
transfer this
Okay,
power to
that
this
is the
DC
main
load.
radial topology.
Okay,
So
that is the
one
main
way
radial
transfer of
topology.
power is
So
possible,
one way transfer of
not
power
the
is
two way,
possible,
from the
not the
generating
two way,
source
from
point
the
of view.
generating
Generating source
source
point of view.
point of view,
It should
generating
not
source point of view.
consume.
It should not
It can
consume.
consume through the DC bus
It
bar.
can consume through the
So
DC
coming to
bus
the
bar.
right side
So coming to the right
topology,
side
that is multi-terminal. If you
topology,
see
that is
this, multiple
multi-terminal. If you
terminals are
see
there.
this,
So
multiple
one
terminals are
terminal
there.
at which the
So
grid is
one
connected.
terminal at which the
At
grid
same
is
terminal,
connected. At
this
same
PV
terminal,
panel is connected.
this
This
PV panel is
terminal 1.
connected.
If you see
This
that
terminal
terminal
1.
3,
If you
this
see that
at this
terminal
DC
3,
bus at a
this
380
at this
volt level,
DC bus
this
at a
wind
380
is
volt level,
connected.
this wind is connected.
Wind generating source is connected.
Wind
Coming to
generating
this
source is
terminal 2,
connected.
if you see
Coming to
another
this terminal 2,
wind
if you
terminal
see
is
another
connected, and you have a
wind
grid is
turbine is
also connected
connected,
at
and
this.
you have a grid is
So
also
you have a
connected at this.
multiple
So you have a
this
multiple
multi-terminals at
this
this
multi
topology. So
terminals
you,
at
if
this
you want to
topology.
disconnect
So
a
if
certain
you want to
terminal,
disconnect a
you can
certain
also disconnect
terminal,
that also.
you can
So
also
these are
disconnect
the
that also.
reconfigurable
So these are the
topology. You can
reconfigurable
disconnect this
topology.
terminal
You can
3 and connect the
disconnect
terminal
this
2
terminal
to
3 and
terminal 1
connect
directly.
terminal 2
That is
to
also
terminal 1
possible.
directly. That is
So
also
coming to this
possible.
next topology, that
So
is the
coming to
ring
this next
topology
topology,
and
that is the
zonal
ring
topology.
topology and
In
zonal
the ring
topology.
topology, if you see, this
In
is
the
a
ring
ring kind of a
topology, if you
structure
see, this
what
is
we
a
have
ring kind
already
of a
studied
structure
in this
what you
power
have
system
already
network, that
studied in this
this
power system
ring type
network,
for
that
generating
this ring
generation,
type for generating
distribution systems,
generations,
and this radial
distribution
kind of
systems,
distribution
and
system.
this radial kind of
And most
distribution system.
important point in
And
the
most
this
important point
ring
in the
topology is
this
such that
radial ring
if
topology is
certain
such that
this
if
suppose
certain
this
this suppose
solar
this
have a certain
solar
problem,
have a
and there
certain
is a fault
problem,
at this
and there
terminal,
is a
this
fault
bus.
at this
So you
terminal,
can
this
disconnect that,
bus. So
but
you
the
can
supply
disconnect that,
will be
but the
possible
supply
through the
will
other
be
path also
possible through the
at the
other path
through
also at the
DC load.
through
So that is the
DC load.
most important, because
So
if
that
you
is the most
disconnect at a
important,
certain
because
point,
if you
then the
disconnect at a
other way
certain point,
path is also
then the
there
other
to
way path
supply
is
this
also
DC
there
loads.
to supply this
Same with this
DC loads.
zonal topology, if you
Same
see,
with this
there
zonal
is a
topology, if
certain
you
zone,
see, there
and
is a
this zone
certain
is
zone,
connected to the
and
main
this
bus.
zone is
And
connected to
if
the
you see,
main
there is
bus.
a two
And
structures.
if you
One
see,
is the
there are
mesh
two
structure.
structures.
Mesh
One is the
structure
mesh
that
structure,
it
mesh
have a
structure
certain,
that
suppose
it
this is the
have a
plant,
certain,
and it
suppose
is
this is
also
the plant,
connected to this
and it is
another
also
bus.
connected to this
And this
another
PV plant
bus,
is connected to
and this
another bus.
PV plant is
And this
connected to
bus is
another bus,
connected to some
and
main
this
bus.
bus is connected
Okay.
to some main
So
bus.
mesh structure
Okay.
is also there,
So mesh
and the
structure
radial
is also
structure is
there,
also
and
there.
the radial
This is the
structure
mesh
is also
structure
there.
that multiple
This is the mesh
topologies are
structure
connected
that
at the
multiple
particular
topologies
bus,
are connected
and this
at the
bus
particular
is
bus,
again
and
converted
this
to
bus
this
is
AC
again
voltage,
converted to this AC voltage, AC
connected to this
voltage, and
AC
connected to this
DC
AC
point of
this
common coupling.
DC
Such
point of
same
common
structure
coupling.
can be followed
Such
at
same
different
structure
zones
can be
also.
followed
So
at different
this
zones
is the
also.
zonal
So
topology.
this is the
Coming
zonal
to this
topology.
classical and the
Coming to this
bidirectional
classical and
DC-DC
the
converter
bidirectional
topology,
DC
if you
converter
see
topology,
from this,
if you see
if you remember
from
that,
this, if you
there is
remember
a
that,
initially there was
there is
one-way
a
transfer of the
initially
power
there
is
was
possible.
one way
That
transfer
suppose
of
you
the
have a
power is
DC
possible.
battery,
That suppose you have a DC
it
battery,
can charge, and
it can charge,
supply power to the
and
load,
it can supply
but
power
it
to the
cannot
load.
discharge through the
But it
same
cannot discharge through the
where
same
the source power is
path
coming.
where the source power is
So
coming.
what will happen that DC
So
battery is
what will
taking
happen
power,
that DC battery is
charging,
taking
and
power,
discharging to some load,
charging, and
and this
discharging to
source
some load,
is some other
and this
place.
source
Okay.
is some
Suppose you
other
have
place.
a AC,
Okay.
a single
Suppose
phase
you
AC
have
supply
a
line,
AC,
what
a single phase
you are
AC
using
supply
in
line,
your
what
home also,
you are using in your
connecting to
home
this
also,
inverter.
connecting to this
So if
inverter.
the supply
So
is
if
there, you
the
should charge
supply
this
is
battery
there, you
and
should
discharge
charge
when the
this
supply
battery
is not there.
and
So
discharge
this
when the
is the
supply is
classical
not there.
type of
So this is the
unidirectional
classical
power
type
flow,
of
which is
unidirectional power
possible
flow,
through certain topologies
which is
such as
possible
buck
through certain
boost,
topologies such as
Chuck
buck
converters.
boost, or chuck
And this
converters.
topologies, that is
And this
unidirectional power flow,
topologies,
but
that is
because this
unidirectional power
inverter is
flow,
not
but
capable
because
to supply
this
to
inverter
this
is not
source,
capable to
this
supply to
single
this
phase supply
source,
line which
this
is
single
coming to
phase
your home,
supply line which energy is
So
coming to
what will
your life.
happen that
So
with
what
the
will happen that
advancement of this
with the
power electronic
advancement
converter, the
of this
bidirectional
power electronic
possibility is
converter, the
also explored.
bidirectional possibility is
This
also
converter
explored.
which I have shown is
This
the blue
converter
line
which I have
is the
shown is the
conventional
blue line
unidirectional,
is the
and in
conventional
the
unidirectional, and
red
in the
it is a bidirectional.
red It is a
Suppose this is a
bidirectional.
battery storage system is
Suppose
there.
this is a battery
Battery is
storage
connected
system
to
is there.
DC-DC
Battery is
converter
connected to
and
DC
is
DC
connected to the
converter
DC bus
and
bar.
is connected to the
When there
DC
is a
bus bar.
need of power at
When
this
there is a
DC bus,
need of
then
power
this
at a this
battery can
DC bus,
discharge at
then this
that particular
battery can
moment,
discharge
and
at
it
that
also
particular
can
moment,
charge. There
and
is
it
a no
also can
kind of
charge. There is a no
separate
kind of
loading kind of system is
separate
connected to
loading
this
kind of
battery.
system is
This is
connected
battery
to this
is such
battery.
that this
This
is
is battery
acting
is
as a
such that this
storage
is
system.
acting as a
Same with
storage
this
system.
ultra capacitor also,
Same
it
with
is
this ultra
connected to same with the
capacitor
DC
also,
bus
it is
bar,
connected to same
and
with the
when there
DC
is a
bus bar,
need of power, it
and when
should
there is a need of
a
power,
charge,
it should
and when
charge
there is a
a charge,
the need
and
in
when
the
there
at a
is a
DC bus bar
the
level,
need
then
in
it
the
should
at a
discharge.
DC bus bar level, then it should discharge.
So this topology is
So
very
this
prominent
topology
nowadays.
is
Where
very
with the
prominent
if you
nowadays.
see
They
this high
with the
voltage
if
electric
you see this
vehicles
high
which is
voltage electric
prominent in
vehicles
our
which is prominent in
this
our
automotive industry currently,
this automotive
that is
industry
also
currently,
utilizing the HEV
that is also
systems,
utilizing the
hybrid
HEV
EV system,
systems,
high voltage
hybrid
this
EV system,
batteries.
high
So
voltage
this
this batteries.
non-isolated
So
bidirectional
this
converter topology
non-isolated
which are
bidirectional
used
converter
that half
topology
bridge
which are
converter,
used
cascaded
that
high
half
bridge
bridge
converter,
converter, cascaded
and
high
it
bridge
is
converter,
more complicated
and
to
it is
control,
more
what we
complicated to
will see in the
control,
further
what we
coming
will see
slides.
in the further
So this is the
coming slides.
question I have
So
given.
this is the
Suppose
question
there
I
is a
have
buck
given.
converter
Suppose
is there,
there is a buck converter is there,
and one curve is given.
and
Curve
one
is such
curve is
that this
given.
is
Curve is
30
such that
volt
this
peak
is
is there,
30-volt
and it is
peak is
going
there,
at a minus
and
20
it is
volt,
going at a
and
minus
this is the
20
T
volt,
on,
and this is
and
the
this
T
is
on,
T off.
and
Same
this is
repetitive
T off.
cycle is followed,
Same repetitive
and this
cycle
is
is
buck
followed,
converter which have
and this
certain
is
VG
buck
voltage,
converter which have
and
certain
you have
VG
a
voltage,
connected to one switch
and you have
and
a
one diode,
connected to one
and this
switch
is
and one
connected to
diode,
inductor
and
and
this is connected
capacitor
to
and one
inductor
resistor.
and
So you
capacitor
have to
and
tell
one
me that
resistor.
what is the
So you
duty
have to
cycle
tell
of
me
this buck
that what is
converter.
the duty cycle
Upper
of this buck
voltage which is
converter.
going is 20
Upper
30
voltage
volt,
which is
and
going is
lower voltage going
30
to the
volt,
20
and
volt.
lower voltage going to the 20
Please
volt.
solve this question. You have
Please solve this question. You
3-4
have
minutes to solve this question.
3-4 minutes to solve this question.
Anybody want to give the
Anybody
answer?
want to give the answer?
Maybe you can try at least before saying no.
Well, you can try at least before saying no.
You are in which year or branch?
You are in
If you
which
are don't
year
study
or
that,
branch?
you have not studied that, you can ask me
You
that
are
how to solve
don't
or
studies that.
if you want.
You have not studied that. You can ask me that how to solve or anything.
This issue is there.
If you want.
that this concept has not been taught in the college or something?
This issue is
We
there,
can
that
make you
this
understand
concept
this
has
question.
not been taught in the
Okay,
college
this
or
is the problem.
something. Then I can
Do you want to
make you
explain the
understand
concept?
this question. Okay, this is the problem. Do you want to explain the concept?
Okay, fine. Let's go to the solution part. What is saying that there is
Okay,
a buck
fine.
converter is there.
Let's
Buck
go to
converter
the
says that
solution
buck
part.
means the voltage
What
at a
is
high
saying
level
that
is
there is a buck
given
converter is
to
there. Buck converter
reduced
says
to a
that
voltage
buck
level with
means
a
the
constant
voltage at
supply.
a high
Suppose
level
this is the
is given to
topology is that you have a
reduced to a
switch
voltage
and
level
you
with
have a
a
diode,
constant supply. Suppose this is
and
the
this is connected to
topology is that
one inductor
you have a
which is
switch
connected
and
to
you
one
have a diode,
capacitor for reducing
and
the
this is
resistance which is
connected to
going to this
one inductor
resistor,
which is connected to one capacitor
and this
for
voltage is there,
reducing the ripple
and this
which is going to
voltage is
this
such that the IL
resistor,
which is I have shown
and
here
this
in the
voltage
graph,
is there,
this
and this
voltage
voltage
variation, this
is such
VL is
that the
variation is
IL
such that
which
it is moving
I have
from
shown here
30
in
volt
that
to minus
this
20 volt.
voltage variation, this
30
VL is
volt is
variation is
upper
such that
voltage
it's
and
moving
minus
from
20 volt is
30
lower,
volt
and
to
this is the
minus
T
20
on
volt.
time and T off time
30
of the
volt is
system.
upper
So
voltage and
suppose
minus
the
20
switch is
volt is
on.
lower, and this
When
is
the
the
switch
T
is
on
on,
time and T
the
off time
voltage
of the
across
system.
this inductor,
So
this
suppose
inductor
the
plus
switch is
minus
on.
VL will
When
be,
the switch is on,
suppose this is the
the
V
voltage
output
across this
and this
inductor,
is the V
this
input.
inductor plus minus,
So V
VL will
input
be,
minus V output
suppose
will
this
be
is the
seen
V output
at that
and this is the
particular
V
moment
input. So
across the
V
inductor.
input
So that
minus
is
V
given at
output will
30
be
volt.
seen
So
at
same
that
when the
particular
switch is
moment
off,
across the inductor. So that is
then
given
this
at 30 volt.
current which is
So
energy
same
stored in
when the
this
switch is off,
inductor,
switch is
that
off,
will freewheel through
then
this
this
diode. So
current
when the
which
switch
is
is off,
energy stored in
the
this
voltage across the inductor
inductor
will be
that will
0
free wheel
minus
through
V
this
output,
diode.
which is given
So
as
when the
minus
switch
20
is
volt.
off, the
Okay.
voltage across the
So how
inductor
to
will be
solve across the
0 minus V
this
output which is given as
actually
minus
this
20 volt.
problem?
Okay.
Major
So
shows
how to
that the
solve
VL
across the
average, that VL
this
average we consider at a
actually
0.
this
Why? Because the
problem?
inductor which
Major such
stores
that
certain
the
energy,
VL
it
average,
should
that VL
dissipate
average
when
we
it
consider
when the
at a
switch
0.
is off.
Why?
When the
Because the
energy
inductor which
free
is
wheels
stored
through this
certain
diode.
energy, it should
So
dissipate
how
when
you will
it
solve
then the
this?
switch is
Using
on.
the power
When
balance
the
equation.
energy
Power
free
balance
wheels
equation
through
shows
this
that
diode.
30 volt
So
will
how you
come
will solve
when
this? Using
you
the
apply
power
this
balance
dt.
equation. Power balance
dt is
equation
there
says that 30
plus
volt
minus 20
will come
volt when 1 minus
you apply
dt
this
is there
dt.
is equal to 0.
dt is
This is
there
the average value is equal to
plus
0.
minus
So
20 volt
30d is
when 1
equal to
minus
minus
dt
20
is there is equal to 0.
sorry
This is the average value is
minus
equal to
20
0.
plus
So
20d is
30d
equal
is
to 0.
equal to minus
So
20
what will happen that
sorry
50d is equal to
minus
20
20
and d
plus
is equal to 2
20d
by
is
5,
equal to
that
0.
is a point 0.4.
So what will happen
So
that
duty cycle will
50d is
come
equal to
as
20
0.4.
and d is equal to
Okay,
2 by
the
5,
answer is
that is a
0.4.
point 0.4.
So this is the
So
major
duty cycle
you
will
can
come
apply
at
this
as
concept in
0.4.
boost
Okay,
converter
the
also,
answer is
this
0.4.
buck boost
So
converter
this
also,
is the
and other
major you can
topologies,
apply
the
this
isolated
concept
converter
in
also,
boost converter
flyback and
also, this
this
buck
kind
boost
of
converter
converter,
also,
forward
and other
converters.
topologies such as
So
isolated
coming to
converter
this
also,
next topic, that
flyback
is
and
the question,
this kind
that
of
is the
converter, forward
statements regarding the
converters.
challenges of the DC
So coming
microgrid.
to this
So
next
you have to
topic,
tell
that
me
is
that
the question,
which
that is
are
the
the
statements
challenges
regarding the
prominent in the
challenges
DC
of the DC
microgrids
microgrid.
and which
So
are
you have
not.
to tell
You
me
have to tell
that
me that which
which
options are
are
correct
the
related to
challenges
this.
prominent in the DC microgrids and which are not. You have to tell me that which options are correct related to this.
And you have, if you have any doubt in between, you can ask me by opening your mic or writing in the chat box.
And you have, if you
This
have
is a
any
kind
doubt
of
in
discussion.
between, you can ask
Okay,
me by
if
opening
you are
your
not
mic or
feeling
writing in the
anything
chat
comfortable,
box.
just let
This
me
is a
know.
kind
Okay?
of discussion. Okay, if you are not feeling anything comfortable, you just let me know. Okay.
Any answers? Just read the statements. You can feel the
Any
genesis
answers?
of the question. Just
Just
read these
read the
statements.
statements. You can feel the
Okay, Ankit is
genesis of the
saying 2,
question.
3, 4, 5 are the
Just read the
challenges.
statements.
Okay, thank you, Ankit.
Okay, Ankit is saying 2, 3,
Anybody else
4, 5
want
are
to
the
try?
challenges. Okay, thank you, Ankit.
Devendra, Rajni?
Uh, Anybody else want to try? Devendra, Rajni?
Okay, let me solve this question. Uh, Actually, all the statements are correct.
Okay, let me
Why I'm
solve
saying
this
that?
question.
Let's read the first
Uh,
statement. If you
Actually,
read
all
this
the statements are
first
correct.
statement, what it is saying that
Why I'm saying that?
the lack
Let's
of
read the
standards in
first
a
statement.
significant
If you
challenge
read
in the
this
widespread
first
adoption of
statement,
the
what is it
DC
saying that
transmission technology.
the
Actually,
lack
that
of
is correct.
standards in a
Why?
significant
You
challenge in
don't
the
see
widespread
lot
adoption
of
of the DC
this
transmission
DC
technology.
distribution
Actually, that
system
is correct.
nowadays. In
Why?
India
You
also, there
don't
is a
see
certain
lot of
number of
this
HVDC
DC
links are
distribution
there.
system
HVDC
nowadays. In
distribution
India
system,
also,
transmission
there is
system
a
is there,
certain number
but
of
you do not
HVDC
find
links are
a
there.
lot
HVDC
of them as
distribution
compared to
system,
this
transmission system is
HVAC
there,
system.
but you do
Okay,
not find
so
a
there is
lot
a
of that
widespread
as
this
compared to this
prominent AC to
HVAC system.
HVAC system are there.
Okay, so there is
HVAC
a
transmission system is
widespread
there, but
this
not
prominent
prominent as
AC to
compared to HVDC.
HVAC
That
system are there.
created a problem in
HVAC
making the
transmission system is there,
this
but not prominent as
proper
compared to
standard of
HVDC.
that.
That
So what is
created a
more
problem
prominent,
in
the
making the
standard go around that,
this
but
proper
not with this
standard of that. So
HVDC
what is
system.
more
So
prominent? The
coming to the
standard
second
go
part,
around
you
that,
also see this
but not with this
circuit breakers also,
HVDC system.
this AC
So
circuit
coming to
breakers.
the second
But
part,
if you
you
want
also
to
see this
use for the DC
circuit breakers
in
also,
form of the DC
this AC
transmission line,
circuit breakers.
so you
But if
have
you
to
want to
make this
use
AC
for the
into DC,
DC
then
in form of the
you can
DC
use
transmission lines,
this
so you have to
circuit
make this
breakers.
AC
So
into
there is a
DC.
no provision.
Then
Suppose this is
you
a
can
DC
use
current.
this
So where you quench this
circuit
fault?
breakers. So
Where
there
you
is a
want to
no
quench?
provision.
Because there
Suppose
is a
this is
no
a
zero
DC
point.
current.
But
So
in the
where you
AC,
quench
if you
this
see,
fault?
there is
Where
a
you
2
want to
points are
quench?
there
Because there is a no
where
zero
you can,
point.
where
But
the
in the
current is zero.
AC, if you see,
At this
there
point,
is a
if you
2
close the
points are
circuit
there
breakers, there is a
where
no
you
kind
can,
of this
where the
reverse
current
tracking
is
voltage
zero.
kind of concept will
At
be
this
there.
point, if you
But
close the circuit breakers, there is
that
a
is
no
not
kind
possible
of
in the
this
case of
race
DC,
tracking
because
voltage
there
kind
is
of
a no
concept will
kind
be
of
there.
zero current.
But
Okay. So
that is not
coming to this
possible in the
third
case of
part, that is
DC
the main
because there is a
obstacle to
no kind
implementation
of
of the
zero
DC
current.
transmission
Okay.
is the lack of
So
existing DC
coming to this
infrastructure.
third
That is
part,
also
that is the
true, because
main
we
obstacle
are
to
currently
implementation of the
in
DC transmission
phase
is
of
the lack of
planting
existing
this
DC
DC
infrastructure. That is
distribution
also true
system.
because
That was
we are
not initially
currently
was
in
case was there.
phase of
The
planting
fourth
this
problem is that
DC distribution
circulating current
system.
and the
That
grounding
was not
issues pose
initially was
problem,
case
especially in
was
the
there.
parallel operation of the
The
DC
fourth problem is
distribution
that
system. That is
circulating
actually
current and
true.
the grounding
In
issues
this
pose problem,
question, you
especially
can
in the parallel operation of the
this statement you can
distribution
understand
system.
from
That
this
is
figure.
actually true.
What I'm trying.
This
Suppose you have
question you can
two batteries.
this statement you can
This is the
understand
one
from this
voltage
figure,
level and
but I'm
second
trying.
voltage level V2,
Suppose you have
R1 and
two
R2.
batteries.
There is a
This
mismatch
is the
between
one
the
voltage level
resistances
and
and you
second
have a
voltage level
certain load.
V2, R1 and
So
R2.
if you want to send the
There is a
power from this
mismatch
load
between the
voltage
resistances and you have a
this V1
certain
or
load.
V2,
So
so there
if
is
you
a
want
possibility
to
that
send the power from
because
this
this
load
V1
voltage
is not equal to
this
V2, that
V1 or V2,
current will move
so
from
there is a
V1 to
possibility
V2
that
or V2 to
because
V1.
this V1
This is a
is
kind of
not equal to
circulating
V2,
current
that
which is
current
not
will move
actually
from
going to
V1
this
to
load.
V2 or
So
V2
that
to
is a
V1.
kind of waste.
This is a kind of circulating current
Waste of
which
energy
is
is there.
not actually
So
going to
what we
this
want
load.
that
So
we
that
want
is a
such
kind
that
of waste.
system to operate in such a way
Waste
that
of
this
energy is
V1
there.
should be equal to V2,
So what we want
and
that we
otherwise
want
this
such that system to
resistances
operate
should
in such a
make
way
that
that this
this
V1 should be
overall
equal to
this
V2
E is equal to
and
V4 pi by
otherwise
2
this
as a concept.
resistances
Okay,
should make that
so that is the
this
main point. That is
overall this
also
E is
AC,
equal
and
to V
also with
plus
the
IR
grounding.
as a constant.
Grounding is
Okay,
also a major
so
problem,
that is the main
because
point.
if you
That is
are
also a issue,
making
and
this
also
DC
with the
distribution
grounding.
system, you need a
Grounding is
wire
also a
to
major problem
take this
because if
current
you
back.
are
You
drawing
can use the
making this
earth
DC
also
distribution
to
system,
for
you need a
negative
wire to
this reverse
take
kind
this
of
current
conductor,
back. You can
so
use
that
the
this
earth
current will
also
flow
to
through
for
the
a
earth also.
negative
That is also
this
some kind
reverse
of
kind
challenge.
of conductor,
So this
so
fourth is
that this
also a
current
kind
will
of challenge.
flow through
Coming to
the
this
earth
fifth part,
also.
that is
That
DC
is also
transmission
some
system
kind
are
of
unable to
challenge.
supply power
So
to
this
AC
fourth is
loads in
also a
this
kind of
industry,
challenge. Coming to this
commercial
fifth part,
buildings
that
and
is DC
residential
transmission
application.
system
That
are
is also
unable
true,
to supply supply power
because
to
if you
AC
see, there
nodes
is
in
a lot of
industrial,
appliances are
commercial
there
buildings
in
and
the
residential
market which
application.
is
That is also
operating on the AC.
because
If you
if you see
put this
there is a
DC
lot of
distribution line
appliances
or
are
a
there
DC
in the
transmission line,
market which
so
is
you need
operating
to
on the
convert
AC. If you put the
you
DC
convert this
distribution line
market
or
which is
a DC
already been
transmission line,
existing from the
so
AC to
you
DC.
need to convert
So
there
this
is
all
you
five are
convert
the
this
challenges.
market
So
which is
this is
already
the
been
figure I have
existing
shown
from the
that
AC
what
to
kind
DC.
of HVDC project are
So
from
this all
are
five are
there
the
in the India.
challenges.
If you
So
see
this is
also
the
there are
figure I have shown
mainly
that
this
what kind of
13. This
HVDC
image
project
is
are from
of
are there in the India.
2017.
If you
It is
see
the
also
old
there are
image.
mainly this
So
13.
if you
This
see that
image
there are
is
from
of
merely
2017. It is the
smaller number
older
of
image.
these projects are there.
So if you see
This
that there are
Vindhyachal BTV
merely a
line, Rihand
smaller
Dadri,
number
one
of
of the
these
plus minus
projects are there.
500 kV line is there.
This
And
Vindhyachal
you also said that
BTV line,
Gaju
Rihan Dadri,
Waka
one
is
of the
also back to
plus
back.
minus
That is a
500 kV
kind of
line is there.
topology which is
And
being
you
used for
also
the
said that
HVDC system.
Gaju
Balia
Waka is also
Bhiwandi, one
back to
kind of
back. That
bipolar
is a
link,
kind
that is
of
a plus
topology
minus
which is
500
being
kV
used
line.
for the HVDC
And the
system.
Mundra, this
Balia
Mahendragarh
Bhiwandi, one
also
kind
a
of
plus minus
bipolar link, that
500.
is a plus minus
And if you
500
see
kV
this
line.
other, that is a
And the
800
Mundra,
kV
this
line, plus
Mahendragarh
minus,
also a
that is
plus minus
Raigad
500. And if you see the
Pugalur and
other,
the
that is
Champa
a
Kurukshetra
800 kV
bipolar link,
lines plus minus,
Northeast
that is
Agra ultra high
Raigad
voltage DC link, that is a
Pugalur
800.
and the Champa
And this
Kurukshetra bipolar link,
Pugalur and
Northeast
the
Agra
Trichur,
ultra
this
high
bipole
voltage
line
DC
plus
link,
minus
that is
320 degree.
800.
So kind
And
of
this
this kind of project is all
Pugalur
going
and the
on, but not
Trichur,
in
this
a
bipole
large
line plus
number as
minus
compared to
320
the
degree. So
AC
kind of this
distribution
kind of
line.
project is all
So this
going
I
on, but
wanted to
not in a
make you
large number
highlight
as
that
compared to
the
the
projects are
AC
going on,
distribution line.
which takes a lot
So
of time
this
to
I
complete.
wanted to
But also this
make
is
you highlight
not
that the projects are going
okay.
on,
Ankit,
which takes
you
a
want to
lot
ask
of time to
something?
complete. But also this is not okay.
Ankit,
Ankit,
you can ask.
you want to ask something?
Ankit, you are not audible.
Ankit, you can ask. Ankit, you are not audible.
Hello.
Yes,
Am
Ankit.
I?
Ankit, you are not audible.
Yeah, Ankit.
Sir, I want to
Ankit,
ask
you are
about
not
back to
audible.
back. Please tell me more about that.
Okay. Suppose suppose you want to implement
Okay.
this DC link. Suppose you have a certain
Suppose
converter.
suppose
This
you
is a
want to
suppose
implement
this is
this
a grid
DC
set
links.
converter is there,
Suppose you have a
and you
certain
need a
converter.
certain converter
This
in
is
the
a
reverse
suppose
direction
this
to
is a grid
take
set
it
converter is there,
this
and
power
you need
back
a certain
to this
converter in the
suppose
reverse
to the
direction
voltage
to
source side
take it this
where the generating is
this
happening.
power
So
back
this kind
to
of a
this
structure is
suppose this is a
same
voltage source
said
side
as the back-to-back
where the
converter
generating is
topology.
happening.
Because if
So
you see
this
this,
kind of structure is
at one
same
side you are
said as
rectifying
the
this voltage.
back-to-back converter
Suppose this is
topology.
there.
Because if you
Suppose you
see
are
this,
generating in the
you
AC
at one
form.
side you
So
are
you are
rectifying
converting to
this
the
voltage.
DC form,
Suppose this is
and
there.
then you are
Suppose you
inverting
are
to
generating in the AC form.
transferring this
So
power
you are
to this
converting to
AC
the
side.
DC form,
So this is a
and then
kind of
you are
topology is the
inverting
back
to
to back. So if you see this,
transferring
you
this
have a
power
two
to this
voltages
AC
as
side.
a plus minus
So this is a
500
kind
kV
of topology is the
and
back
at
to
a
back. So
generation
you
side,
if
and
you see
same with
this,
this
you have a
500
two
kV to
voltages
this.
at the plus
So
minus 500
maintaining this
kV,
voltages
and at a
polarity, you can
generation
transfer
side the
this
same with
power.
this
Or
500 kV
otherwise, you can
this.
also use
So
this
maintaining
voltage
this
level. Suppose
voltages
this is a
polarity,
500
you can
kV line,
transfer this
and you
power.
maintain the
All
300 kV
otherwise you
line.
can
So
also
you can
use this
transfer the power
voltage level.
from
Suppose
this
this is a
500 to
500 kV
300,
line
and
and
if
you
you
maintain the
maintain this
300 kV line.
otherwise,
So
that
you can
500
transfer the
kV to
power from
300
this
kV,
500
so
to
you can
300,
transfer from the
and if you
opposite side
maintain
also.
this
This is a kind of
otherwise this
topology is the
500
back to
kV
back,
to
that
300 kV, so
one
you can
is
transfer
can
from
act
the
as a
opposite
source,
side
one
also.
can act
This
as
is a
a
kind
load.
of topology is
So
the
you can
back to
transfer
back,
from the
that
both
one
sides.
kind
That is
one
also
is
very
can
important
act as
for
a source, one
connecting the
can
multiple
act as a
HVDC
load.
lines.
So you can
Okay,
transfer from the
I
both
hope
sides.
that I have
That is
cleared
also
your
very
doubt.
important for connecting the multiple HVDC lines. Okay, I
uh,
hope that I have
Coming to
cleared your doubt.
this important topic, because after this we will
Coming to
move
this
forward to this AC
this
microgrid
important
operation
topic,
mode.
because
Further we
after
will
this
make
we
you
will
understand the different
move forward to
inverter
this AC
topologies such as
microgrid operation
grid
modes.
forming,
Further
grid
we will
following
make you
kind of structure.
understand the different
At that point
inverter
you need to
topologies such
understand
as
this
grid
currently what I
forming,
am teaching.
grid following kind of a structure.
Suppose there are three
At
modes of
that point you
operation are
need
there
to
generally.
understand this
One is the
currently
grid
what I
connected
am teaching.
operation mode, second is the islanded
Suppose there are
operation
three
mode,
modes of
and
operation are there
third is
generally.
that when the
One is the
islanded
grid
is
connected
coming
operation
back to
mode,
the grid
second is the
connected mode.
islanded
So
operation
first
mode,
operation is that
and
grid
third is
connected,
that when
second
the
operation is
islanding is
islanded mode,
coming back to
third
the
operation is
grid
that
connected mode.
islanded
So
when
first
the
operation is
system
that grid connected. second
situation,
operation is
and it
islanded mode.
coming to
Third operation
existing
is
to
that
connecting to
islanded
this
when the
utility
system
grid,
is
that is
in
third
islanded
operation.
situation,
So
and
in the
it
grid
coming to
connected mode, in
existing
the
to
normal
connecting to
operation, this is
this
known as the normal
utility grid,
operation,
that is
your
third operation.
microgrid is
So in
connected
the
to the
grid
main
connected
MV
mode,
line,
in the normal
because
operation, this is known
you
as the normal
connect this
operation, your
this
microgrid is
generating main
connected to the
utility with
main
a point
MV
of
line,
common coupling through
because
PV circuit
you
breaker,
connect
and you
this
connect this
this
microgrid,
generating main
this kind of
utility
structure.
with a point of
So
common
this
coupling through
PV,
CV
this point of
circuit
common
breakers,
coupling,
and you
connect
connect
this
this microgrid,
MGN, this
this kind
microgrid
of
operation to
structure.
utility
So
grid
this
to the
CV, this
MV
point
line.
of common coupling,
So this
connect
supplied
this
can be
MGN, this
injected,
microgrid
because the
operation to
microgrid
utility
can
grid
distribute
to
this
the
power,
MV line. So this
distribute this
supplied
power to
can be
this
injected
microgrid, and
because the
also
microgrid
if you're
can
connecting the load,
distribute this
this can
power,
also
can
send this power to the load also.
distribute this power with this
Coming to the
microgrid, and
second
also
point,
if
that
you're
power
connecting the load,
differences for the
this can also
microgrid
send
control
this
are
power to
issued
the
by
load
the
also.
MGCC.
Coming to the
That is
second point,
most
that power
important, because the
differences for the
microgrid central
microgrid controller
controller is very
issued by the
important if you have
MGCC.
a
That
multiple
is
number of
most
microgrids.
important, because a
So
microgrid
this
central
control
controller is
structure,
very
which
important if you
I
have a
am going
multiple
to
number of
explain you in the
microgrids.
further slide.
So this control
This
structure
MGCC control the
which
multiple
I am
distributed
going to
generator, which
explain
is
you in the
known as the
further
PV
slides.
inverter
This
controller based
MGCC
topology.
control the multiple distributor
And the
generator,
distributed
which
generator
is known as
operates
the
in the
PV
PQ
inverter
mode. PQ mode
controller based
is the
topologies.
power and reactive power
And the
sharing
distributor
mode
generator
operation.
operates in the
And in the
PQ mode. PQ
islanding
mode
mode,
is the
this same
power
operation is
and reactive
happen,
power
but
sharing
only
mode
difference is such
operation.
that it is
And in
not
the
connected with the
islanding
grid.
mode,
So
this
it is a
same operation
kind of
happens,
system that its
but only difference is
self-performing
such that
inverter is
it
there.
is not
So it
connected with the
forms the
grid. So
separate
it is a
grid.
kind
Separate
of
grid
system
can
that
exist,
its
which form the
self-forming
voltage
inverter
which
is
is
there.
specified
So
with the
it
grid
forms the
itself,
separate
that
grid.
is the 230 volt
Separate grid
for
can
generating the
exist,
load.
which form the
So
voltage
if
which
you
is
see, the 1
specified with the
DG may
grid
be
itself,
operating in the
that is the
VF
230
mode,
volt
that is a
for
variable
generating the
frequency
load.
mode, and the
So
other
if you
is
see the
operating
1
in the
DG
PQ
may be
mode, with the
operating in the
multiple distributed
VF mode, that
generations
is a
in that.
variable frequency mode,
So
and the
coming
other
to
is
this
operating in
islanding
the
of the
PQ mode if
microgrid,
the
which I
multiple
have
distributed
already
generations you have.
explained you in the
So
tutorial
coming to
5th,
this islanding of the
and
microgrid,
I am
which I have
explaining here also
already
that islanding is the critical
explained you
and
in the
unsafe condition
tutorial
in which the
5th,
distributed
and
generator, such as
I am
the solar
explaining here
system,
also that
continues to
islanding is
supply
the
power to the
critical and
grid while the
unsafe condition
electricity
in which the
utility is down.
distributed generator,
Okay,
such as the solar
so
system,
if the
continues to
grid
supply
don't
power
get
to the
the
grid while the
power supply
electricity
from the
utility is
microgrid,
down.
and you are
Okay,
continuously
so
injecting the power at
if
a
the grid
particular
don't
point,
need
so
the
the voltage
power
will
supply from
rise
the
at that
microgrid, and
particular
you
point,
are
because
continuously
at that
injecting the
particular
power
point
at a
you are
particular
injecting
point,
power
so
from
the
this
voltage will
microgrid,
rise
and
at
the
that
grid
particular
don't
point,
need that
because
power,
at
because
that
it is
particular point
already in the
you are
circular
injecting
condition.
power from this
Okay,
microgrid,
so the
and the grid
voltage
don't
at the
need
particular
that
point
power
will
because it
increase,
is
and there
already
is
in the
a kind
circular
of
condition.
issue such that
Okay,
the voltage
so the
imbalance can also
voltage
occur,
at the
and
particular
some
point
high
will
frequency
increase,
noise
and
can
there is a
also
kind
come
of
into
issue
comment.
such that the
So
voltage
issue is
imbalance
such
can
that
also
there is a
occur,
safety
and
concern that
some
the
high
utility
frequency
worker
noise
may
can
get
also come
exposed to
into
the
prominence.
hazards or the shocks,
So issue
and
is
the
such that
damage
this
to
is
the
a safety
customer
concern that a
appliances is
utility
also one
worker
kind of
may get
situation. Suppose
exposed to
you
the
have a
hazards
connected
or
load
the
also,
shocks,
so
and the damage to the
there is a
customer
certain
appliances is also
specified
one kind of situation.
specifications
Suppose
are there,
you have a connected load
above
also.
which above
So
that voltage level you
there is
should
a
not
certain
operate that
specified
appliance.
specifications
And
are there,
inverter damage leads to the
above which above
malfunction for
that
the
voltage
inverter,
level you should
because
not
it is
operate that
continuously injecting
appliance.
this power.
And inverter
And there are
damage
two
leads
kinds
to
of
the
islanding
malfunctions
mechanism,
of the
that is
inverter
active and
because it
passive,
is
which already I have
continuously
explained.
injecting this power.
Further moving to
And
this
there are two
control
kind of
part,
islanding
that is the
detection,
most
that is
important.
active and
So if
passive,
you
which
are
already I
going
have
from
explained.
this
Further
research
moving to
areas,
this control part,
and
that is the
if you
most
are
important. From if you are
want to
going
study
from
about
this
this microgrid,
research
so
areas,
you have to
and if
this
you are
understand this
want to study
controlling
about this
architecture.
microgrids, then you
So
have
there
to
are two kinds of DG
this
control is
explain
there.
understand this controlling
Distributed generation
architectures.
control. One
So
can be
there are two
conventional,
kinds
that
of
is the
DG control
synchronous
is there.
generator based.
This
Second is the
distributed
inverter based
generation
DG.
control.
So
One can be
synchronous based,
conventional, that is the synchronous
this
generator
synchronous
based.
generator control
Second
you
is the
already
inverter based
know
DGs.
that
So
through the
synchronous based
suppose
this
if you have
synchronous
a
generator
certain
control you
generation is
already
there and
know that
certain demand is there.
through the
So if there is a
valve, suppose
suppose
if you
there is
have
a
a
demand
certain
is greater
generation
than
is there
generator,
and
then
certain
you
demand is
open the
there.
valve of
So
the
if
steam
there is a deficit,
and
suppose the
generate
demand is
more
greater
power,
than
so
generator,
that you should
then
meet this
you open
difference,
the
that is
valve
the
of the
PD minus
steam
PG.
and
And there is a situation
generate
is
more
that the
power, so
generation
that
is
you should
greater
meet
than the
this
demand.
difference, that is
So
the
in
PD
that case,
minus
you
PG.
should take
And
the
there is a
you
situation
should
such
not
that the
generate that
generation is
much power.
greater
Only
than
you
the
should
demand.
generate that
In
PD
that
amount of
case,
power.
you should
So
take
that
the
is kind of
you
valve
should
control.
not
That is the
generate that
governor
much power.
control
Only you should generate
is
that PD
mainly
amount of power.
prominent in
So that
controlling
is
this
kind
valve.
of valve control control,
and
that is the
taking the
governor
difference of
control,
this generation power
is
and the demand
mainly
power.
prominent in
And coming to
controlling
this
this well,
inverter based DG,
and
there
taking
is
the
a two
difference
kind
of
of
this
operation mode,
generation power
what I
and
have
the demand
told you,
power.
that is a grid
And
connected
coming
mode
to
and
this
the
inverter
islanding mode.
based DG,
And
there
in the
is a two
grid
kind of
connected mode
operation
also,
mode,
there are
what I have
certain
told you, that is a
architectures which
grid
is
connected
based
mode
upon
and the
this control
islanding mode.
topology, that is
And
grid
in the
feeding,
grid
because
connected mode also,
this
there are
microgrid
certain
is sending power
architectures
to this
between
grid
based upon this control topology,
when there
that is
is a
grid
need,
feeding,
and grid
because
supporting. Grid
this
supporting is
microgrid is sending power to this
such that
grid when
it
there
is
is
a
a need.
part of this
And
grid,
grid supporting,
consider
grid
as a part
supporting
of
is
grid,
such that
and as a
such that
support. Suppose
it
you
is
have a
called, it is a
100% power
part
if
of
there
this
is a
grid,
need.
consider as a part
Suppose
of
the
grid. And
70% is
as a
coming from the
support,
grid,
suppose
then
you have a
30% should
100%
generate
power
from
is
this
there is a
microgrid.
need.
So this kind
Suppose
of
the
topology
70%
is
is
kind
coming
of
from the grid,
supporting
then
topology.
30% should
And there is
generate from
grid
this
feeding
microgrid.
strategy.
So
When there
this
is a
kind of
surplus,
topology is
then
kind
it
of
can give to
supporting
this
topology.
grid.
And there is
This
grid
kind of
feeding
architecture is
strategy,
there.
when there
Not
is a
there is a
surplus,
fixed
then
amount of
it can
certain
give to this
percentage
grid.
is there. Okay.
This kind of
Same with
architecture
this
is there.
islanding
Not
mode,
there is
that is
a
it
fixed
can
amount
also
of certain
act as a grid forming,
percentage is
grid
there.
feeding, or
Okay.
grid support.
Same with this islanding mode,
So
that
coming
is
to
the,
this
it can also act as a grid forming,
control
grid
of this
feeding, or grid
inverter
support.
based DGs,
So
there are
coming to
certain
this
points which you
control
have
of
to
this
understand that
inverter
due to
based
this
DGs,
internal
there
characteristic,
are certain
most
points which you have to
distributor generator is what kind
understand
of
that
system, that
due to this
solar,
internal
solar is there,
characteristic,
wind is
most
there, and other kind of thermal
distributor
is there.
generator is what kind of system,
These are
that
not
solar,
suitable for the direct
solar is there,
connection to the
wind is there,
electricity
and
network,
other kind
because
of
you
thermal is
cannot
there.
connect directly
These
to
are
this
not
grid.
suitable for the
Okay,
direct connection to the electricity
this
network,
microgrid
because
you
you
cannot
cannot
directly
connect
connect to this grid.
directly to this
There is
grid.
certain kind of
Grid,
voltage,
this
frequency,
microgrid,
kind
you
of
cannot directly
kind
connect
of
to this grid.
reference will be there,
There is certain kind of
and it
voltage,
should synchronize with that.
frequency,
This power, therefore, power
kind of
electronic
reference should be
interfaces are
there,
required. And second
and
point
it
is
should
that the
synchronize
most
with that.
conventional power
This
electronic
power, therefore,
topology is
power
the
electronic
back-to-back
interfaces
structure,
are
which I
required.
will show in the
And
further
second
slide.
point is that
That
the
with
most
two
conventional
VSTs,
power
two
electronic
voltage
topology
source
is a
converters,
back-to-back
one
structure,
for the
which I will
generation
show in
side
the further
converter
slide.
and
That
other
with two
for the
VSCs,
grid side
two
converter.
voltage source converters,
And coming to
one
this
for the
third part,
generation side converter
second
and
point I have
other
already
for
explained,
the
that
grid
you
side
need
converter.
the two kinds of
And coming to this
back-to-back
third part,
structure of this
that
voltage side source
second point I have
converter, one
already
at the
explained,
grid
that
side,
you need the
one
two kinds
which
of
is at a
back-to-back
at the
structure of this
microgrid side,
voltage side source
where the
converter. One
microgrid
at
should
the grid
generate
side,
and synchronize with the
one
grid power,
which is
grid voltage and
at the
frequency.
microgrid side,
So
where
generator
the
side third
microgrid should
point, the
generate and
generator
synchronize with
side
the grid
converters
power,
are usually
grid
controlled to
voltage and
implement
frequency.
at a MPPT,
So
which I will
generator
show
side's
you
third
when the
point,
PV
the
is connected to
generator
system,
side
how
converters are
to be
usually
this
controlled
controlled.
to implement
And
at
the
a
grid side
MPPT,
converter
which
is
I will
usually
show
a
you
three-phase
when the PV
inverter,
is
which is
connected to system,
same as a
how should
voltage
you
and
this
frequency of
control.
this grid
And the
itself.
grid side converter is
And the
usually a
fourth point
three-phase
is such
inverter,
that
which is
for a
same
grid
as a
connected
voltage and
mode,
frequency
this
of this
AC
grid
voltage and
itself.
frequency are supplied
And
from
the
the grid.
fourth point is such that
So
for
all
a grid
dispatchable
connected mode,
DCs
this
inverter
AC
must be
voltage and
controlled in the
frequency are
PQ
supplied
mode
from
to
the
give
grid.
power. This I will show
So
with
all
this topology.
dispatchable DCs
So
inverter
this
must
is
be
the
controlled in the PQ mode to inject power.
basic
This I will
fundamentals
show
to
you with this
understand the
topologies.
different topologies.
So this is the
So here I have given the four
basic
images.
fundamentals
This is the
to
A image.
understand the
This is
different
the
topologies.
4B,
So here I have
and D.
given the four
You have to
images.
match
This is the
with
A
this
image.
1, 2,
This is the
3,
4
4, that
4B,
which
C
topology
and
is
D.
meeting with
You
this
have to
particular
match with
topology.
this
That is whether
1,
the
2, 3,
A
4
is
that
grid forming,
which
grid
topology
feeding,
is
or grid
meeting with
supporting
this
voltage source,
particular
or grid
topology.
supporting
That is
current.
whether the A is grid
You have
forming,
2 minutes to
grid
solve this
feeding,
question.
or grid supporting voltage source, or grid supporting current
This
source.
I will explain in the further, because
You
this
have
is the
2
most
minutes to
fundamental
solve
to
this question.
understand that
Okay?
which topology, which control
This
topology.
this I will explain in the further, because this is the most
Just,
fundamental to
try
understand that
once
which topology, which control
by seeing
topology
this
is there.
current source and voltage sources.
Just try once by seeing this current source and voltage sources.
Dhanni is asking that what is grid forming and grid following. This I read as the grid following inverter acts as
Dhani
a
is
voltage
asking
source,
that
and
what is
grid
grid
forming
forming and grid
it is a
following.
current
This
source. It is
I
a
read
merging
as
of
the grid
current
following
source
inverter acts
inverter.
as a voltage source
Yes,
and grid
I will
forming it
explain
as
that
it
in the
is a
further
current
slide.
source. Is
This
there
is the
any
first
advantage of
I
current
have
source
put it
inverter?
because of this fundamental
Yes, I will
concept I
explain
wanted to
that in the
explain.
further slide. This is the
So
first
just solve
I have
through
put it
your
because of
fundamental
this
concept
fundamental
that
concept I
at
wanted
least
to
to
explain.
give a try, and
So
in the
just
further
solve
slide
through your
you will
fundamental
get to
concept
understand that
that at
how
least
to
to
understand
give a
that
try,
which topology is
and in
grid
the
forming,
further slide
which topology is
you
the
will
grid
get to
feeding.
understand that how to understand that which topology is grid forming,
Just
which
give a
topology
try.
is the grid
At
feeding.
least give wrong answers also, which will make you understand that at
Just
what
give a
point
try.
you were wrong.
At least give
Okay,
wrong answers also,
at
which
least give
will
a try.
make you understand that at what point you were wrong. Okay, at least give it a try.
Any answers?
Any answers?
Okay, let me explain you this concept. If you see that
Okay, let me explain
from the
you
fundamental concept that
this concept.
how you connect this voltage
If
source.
you see
Let me
that
take another
from the
slide
fundamental concept
for
that
this purpose.
how you connect this voltage source. Let me take another slide for this purpose.
Suppose you have a voltage source. Okay, so how you represent this voltage source? You represent
Suppose
it
you
such
have a
that
voltage
you
source.
have a voltage source
Okay,
and
so
you
how
will
you
sum with
represent this
some
voltage
internal
source?
resistance.
You represent it such
And
that
how you
you have a
represent one
voltage
current
source
source is such that
and you
current
sub
source
with some internal
that
resistor.
it have a
And
current
how
source,
you
and in
represent one
parallel
current
you
source is
connect a
such that
resistance to that,
current source
and it is feeding to some
that
power.
it have a
So
current
main
source
fundamental
and
concept
in
is such
parallel you
that
connect a
it has
resistance
a
to that
certain voltage
and it is feeding to some
which is
power.
being maintained.
So main
If you see
fundamental
this,
concept is
this
such
voltage is
that
constant
it have a certain
and
voltage
current is variable.
which is being
Okay,
maintained. If you see this
how the
voltage
current
is
is
constant
will vary is
and
depend
current
upon
is
the load.
variable. Okay,
Coming
how
to
the
this
current is
concept of current source,
will
here
vary,
the
it
current is
depend upon the
constant.
load.
Okay,
Okay,
and how the
coming to
voltage
this
is
concept
variable.
of current
How
source,
this is
here
variable
the current
based
is
upon
constant.
this
Okay,
topology of
and
this
how the
load,
voltage is variable. How this is
because V
variable
is I
based
times
upon
of Z.
this
Z is
topology of this
variable,
loop,
I is constant, so V is
because V
variable.
is I
Okay,
times of Z.
and in concept
Z
of this
is
V is equal
variable,
to I
I
Z,
is constant,
here the
so V
voltage is
is variable.
constant.
Okay,
So if
and
you
in
vary the
concept of
Z,
this V
the
is
I
equal to
will vary.
I Z,
So this is the
here the
fundamental
voltage is
concept of this
constant,
voltage source and
so
the
if you
current
vary
source.
the Z,
Constant
the
voltage
I
source
will
and
vary.
constant current source.
So this is the
So coming
fundamental
to this
concept of this
topology, if you
voltage
see
source and
the
the
first
current source,
topology.
constant
First
voltage source and
topology is such
constant
that
current source.
it is
So
forming a
coming to
voltage
this
source.
topology, if
If
you
you see,
see the
it
first
is
topology,
connected to a
first topology is
internal
such that
resistance,
it is
some
forming a voltage
resistance
source.
or some
If you
impedance.
see, it is
So
connected
if
to
you see
a
that the
internal
voltage here
resistor,
can be constant.
some resistor or some impedance.
What is the main
So
fundamental of a
if you see that the
grid
voltage
is such
here
that
can be
it have a
constant.
voltage of certain
If the
specified
what is the
amplitude,
main fundamental of
and
a
it is also have a
grid is
certain
such that
frequency.
it have a
And
voltage
with
of certain
percentage THD, the
specified
total
amplitude,
harmonic distortion is
and it is
much
also
lower
have a
as
certain
compared to
frequency.
IEEE. It
And
should
that
be less than
percentage
5%,
THD, the total
the
harmonic
overall
distortion,
THD.
is
Okay,
much lower as compared
so
to
if you
IEEE.
maintain
It
that
should be
voltage
less
and
than 5%.
frequency,
The
then
overall
this you
THD.
can say that
Okay.
this RMS voltage is
So
constant.
if you maintain that
Okay,
voltage and
the voltage
frequency,
can be constant.
then
So
this
it
you
says
can
that
say
it is
that this
forming a
RMS voltage
certain
is
kind
constant.
of grid
Okay.
whose
So
voltage
voltage
is
can be constant.
constant,
So it
and
says
it can
that it is
supply
forming a
any amount of
certain
current.
kind
How
of
it is
grid
maintaining the voltage
whose
constant?
voltage is
Through a
constant
voltage
and
controller.
it can supply
This voltage
any amount
controller is
of current.
taking
How it is
the
maintaining the
reference from
voltage
where?
constant?
It is
Through
taking
a
from
voltage
reference
controller.
V reference
This
and
voltage
omega
controller
reference
is
from the
taking
grid itself.
reference from where?
Okay,
It is taking
so
from
it is
reference
taking
V
from the V
reference and
voltage
omega
reference and the
reference from
frequency
the grid
reference from the
itself.
grid, and
Okay,
controlling the
so
voltage
it is
such
taking from
that
the
maintaining is
voltage reference and
same
the
as
frequency
that of the
reference
grid.
from the
So
grid
this
and
you can say
controlling the
that
voltage
first image
such
as a
that
grid
maintaining
forming.
is same
This
as
is
that
forming
of
as
the
a
grid.
grid
So
by
this
taking the
you can say
voltage and the
that
frequency
first image
reference as
as
the
a
same
grid
as the grid.
forming.
Okay.
This is
Coming to
forming
the
as a
second
grid
part,
by taking the
second image,
voltage and the
if you see,
frequency reference at the same as the grid.
this is a
Okay,
working as a
coming to
current
this
source.
second part,
Current source, what I have told,
second image,
the
if you
voltage
see,
can be variable.
this is
Voltage
a
can be
working
variable,
as a current source.
but
Current
the
source, what I
current
have
is
told, the
current. If you
voltage
see,
can
this
be variable.
constant. So
Voltage can be
how
variable,
you can maintain this
but
constant
the
current?
current is
Constant current
current.
is
If
such
you
that
see this
power
constant,
is if you see
so
that power is
how you can maintain
VRMS
this constant
I
current?
RMS cos phi if you are
Constant current
considering
is such that
frequency.
power is
So
if
if
you
you
see
see
that
that
power
the
is
current is
VRMS
variable here,
IRMS cos
whose
phi if you are
reference
considering
comes from
single
this
phase.
power term.
So if you
And
see
same with
that
the Q,
the
that is the
current is
VRMS
variable here,
IRMS cos phi.
whose reference comes
If you
from this
see this,
power term.
current is
And same
what
with the
it can
Q,
give.
that is the
Current is
VRMS
here,
IRMS
the
cos phi.
constant, this
If you see this,
current
current
feeding
is
mode is there,
what
grid
it
feeding
can
mode is
give.
there,
Current
and
is
it can
here
supply
the
any amount of,
constant.
this is
This
a not
current feeding
non-constant
mode is
current,
there. Grid feeding mode is there,
non-constant current.
and it
It
can
is a
supply any
just
amount.
kind
This is
of
a
a current
not
source, but which
non-constant
is
current.
variable,
Non-constant
which is
current.
variable,
It
not
is
a
a
constant.
just kind of a current
This is
source, but
varying.
which
This
is
current is
variable.
varying
Which
with
is variable,
respect to
not a
this
constant.
reference of the P and the Q
This
reference
is
taken from
varying.
the
This
grid
current
itself.
is varying
Okay,
with respect
this
to this
current control,
reference of the
this
P and
current
the
which
Q
is
reference
going to
taken
this
from the
forming this
grid itself.
inverter is being
Okay, this
controlled.
current
This
control,
controlled
this
with
current
respect to
which is
P reference
going
and
to
the
this
Q
forming
reference,
this
and
inverter
this
is
current
being
is variable.
controlled.
Current is
This
variable.
control with
Same
respect to
amount this
P reference
voltage
and the Q
at same
reference,
point of
and
time.
this
This
current is
voltage
variable.
across
Current is
this
variable.
current
Same
source is
amount
being
this
maintained
voltage
with
at same
respect to
point
this
of
P and
time.
Q.
This voltage
Suppose
across
if you
this
see this
this
power is V
current
RMS
source
I
is
RMS
being
cos
maintained
phi. If
with
you are
respect
varying
to
this
this P
P,
and Q.
this I should
Suppose
vary.
if you see
I
this
should
power
vary.
is VRMS
If you are
IRMS
not
cos
varying
phi.
this
If
current
you are
at the
varying this
same
P,
amount, this
this
voltage will
I
vary
should vary.
to maintain
I
this
should
power
vary.
what is
If
being
you are
supplied.
not varying
So
this
what is
current at
happening
the
that
same amount, this
I am
voltage will
maintaining this
vary to
VRMS as a
maintain this
constant.
power what
The
is being
I
supplied.
am
So
varying this
what is happening
I
that
with
I
respect
am
to P.
maintaining this VRMS
Same
as
I
a
am doing with
constant.
this Q
The
also. I am
I am
maintaining this
varying this
VRMS as a
I
constant.
with
I
respect
am
to
varying
P.
Q as a Q
Same
is
I am
varying
doing
or
with this Q
increasing.
also. I am
My I
maintaining
should
this
also
VRMS as
increase.
a constant. I
So
am
it
varying
is
Q
forming
as a
as a
Q is varying or
grid
increasing.
feeding mode,
My
because
I
grid
should
feeding
also
means
increase.
if there is a demand in the
So it
grid,
is forming as
you
a
should supply the
grid
power.
feeding mode, because
Otherwise,
grid feeding means
there is an
if there is
impact
a
on this
demand
zero
in the grid,
voltage.
you
So
should supply the
this
power.
second topology is same
Otherwise,
with this
there
grid
is an
feeding mode.
impact on this euro voltage.
Okay. Coming to
So
this third part.
this second
Third part
topology
is
is
such that
same with this
this is a
grid
grid
feeding mode.
supporting voltage source.
Okay.
That is the
Coming to this
see
third
this
part.
third.
Third part
Why?
is such that this is the
Because if
grid
you see this,
supporting
I am
voltage
maintaining
source.
the
That is
voltage
the
constant because
C
it is a
is
grid.
third.
I
Why?
am
Because
utilizing it
if you
for
see
the
this, I
voltage,
am maintaining the
this
voltage
support, this
constant
grid
because
support,
it is a grid.
and whose
I am
reference, because
utilizing
for
is for
supporting
the
the grid
voltage.
you need the power
This
and the
support,
Q
this grid
reference,
support,
because only
and
that
whose
you can
reference,
check
because
that
for
whether how
supporting
much
the
power
grid
is
you need the
demanded
power and the Q reference,
from the
because
inverter which
only
you have,
that you can
which
check that whether
microgrid
how much power is
microgrid
demanded
inverter
from
which
the
you have. Okay.
from the
So I am
inverter
taking
which you
first the
have,
Q out
which
and the
which
P out a
microgrid
reference.
microgrid inverter which
And
you
this
have.
through
Okay,
the Drup
so
law,
I am
which I
taking
will
first
explain
the
in the
Q
further
out
slide.
and the P out
I am
reference.
getting this V
Okay,
reference and the omega
and this
reference.
through
By
the
that
Drup
I am
laws, which I
controlling
will
this
explain in the
our
further
inverter.
slides.
So this
I
kind
am
of
getting
structure
this
is
V
such that
reference and
it
the
is
omega
supporting
reference.
the
By
grid by
that I
taking the
am
P
controlling
out
this
and the Q
our
out a
inverter.
reference.
So this
And
kind of structure
further
says
that
that
it is
it is
controlling this
supporting the
voltage.
grid by taking the P
Same with
out
this,
and the Q
I
out
am,
a reference,
if you want
and
to feed
further
as a
that
current
is
source,
controlling
because
this
if you
voltage.
want to maintain the voltage as a
Same with
constant,
this,
so
I am
power
if you want
should
to
vary as
feed
compared
as
to
a
the
current source,
current should
because
vary
if you
as
want to
compared to the
maintain the
speed.
voltage as a
For that,
constant,
what
so
you need,
power should vary
for
as
that
compared to
you
the
have to
current
maintain
should
this
vary
voltage
as compared to
constant,
this
the
P.
amplitude
For that what you need,
amplitude of the voltage and
What
the
for
frequency of
that
the
you
voltage you
have
have
to
to maintain
maintain this
constant.
voltage constant,
For
the
that you need certain droop
amplitude of
loss,
the voltage
and
and the
you
frequency of
take
the
this
voltage you have to
frequency and the
maintain
voltage
constant.
from the gate
For
to
that
the droop
you
loss
need certain
and
droop loss,
maintain what
and
amount of
you
P
take this
and Q you
frequency and the
needed.
voltage from the
For
grid
that you should
through the
control this
droop loss,
current
and
by
maintain
maintaining
what
this
amount
voltage as a
of
constant.
P and Q you needed.
So this kind
For
of
that you
topology,
should
okay,
control this
then you are
current
asking please
by
repeat.
maintaining
Okay,
this voltage as a constant.
let me explain you further.
So this
Okay,
kind of topology, okay, then he is
let me
asking please
explain
repeat.
you
Okay, let me
further.
explain you further.
Taking this
Okay,
slide. Okay.
let me explain you further.
Let's
taking
going
this
to the
slide.
grid forming mode.
Okay.
First example says that I am forming a grid.
Let's going to
Forming a
the
grid
grid
means
forming mode.
what is that?
First
It is
example
not
says that
connected to
I'm
grid. Suppose it's running
forming
in
a
handle
grid.
mode, but you should generate.
Forming a
Suppose you
grid
have a
means
home
what is that? It is not connected to
and
grid. Suppose
you
it's
need
a
DC
islanding mode,
voltage and
but
50
you
hertz
should
supply,
generate. Suppose you have
and
a
you have
home
one inverter which is
and
not
you
connected to the
need this
grid.
3 voltage
You have to
and 50
generate
hertz
certain
supply,
power from the
and you
inverter,
have one
inverter which
which
is
is not
connected to some
connected to the
solar,
grid. You
and
have to
you
generate
should give
certain
this
power
power
from the
to this node.
inverter,
So how you will
inverter which
generate
is
this 3
connected to
to
some
30
solar,
volt and 50 hertz
and
supply?
you should
You
give this power
have
to
to
this
take
home.
certain
So
reference
how
node.
you will generate this 3
According
to
to
30
that,
volt and
your
50 hertz
controller
supply?
should define
You
that how
have to
much
take
amount you should
certain
feed.
reference, no?
Okay, so that I
According
have
to
explained in the
that, the
first
controller should
this
define that
image
how much
itself,
amount you
that
should feed.
you take the
Okay,
voltage and
so
frequency
that I have
difference
explained in the
forming the grid
first
and control
this
the
image
voltage
is
based upon
itself
that
that
by
you
maintaining this
take the
V as
voltage
a
and
constant.
frequency reference,
Because at
forming
the
the
home
grid,
also
and
you
control the
maintain the
voltage based upon
and
that
the
by
frequency at
maintaining
a
this V
constant
as a
level,
constant.
and current you
Because
can
at the
increase.
home
You can
also you
connect the
maintain the
50
voltage
appliances, 100
and the
appliances, the
frequency at a
current is
constant
varying but the
level,
voltage is
and
constant.
current you can increase.
And
You
in the
can connect
second
the
figure,
50
what I have
appliances,
showed
100
you,
appliances, the
here
current
it
is
says
varying
that
but the voltage is
suppose
constant.
this is a current source.
And in the
Current
second
source is
figure,
here,
what I have showed you,
and
here
it
it
is
says
taking
that
P and
suppose
Q
this
as
is
a
a
reference.
current source,
Okay, the
current
power
source
is
is there,
VRMS, IRMS,
and it is
cos phi.
taking P and
One
Q
kind
as
of
a
system,
reference. Okay,
and Q
so
is that
power is
VRMS,
VRMS,
IRMS, sin
IRMS,
phi.
cos phi.
Okay,
One kind of
so
system,
if the
and Q
sudden
is
increases
that
power is there,
VRMS,
so what will
IRMS,
happen if
sin
the
phi.
your current
Okay,
is not increasing
so
at the same
if the
amount,
sudden
your
increases
voltage
power
will
is
get
there, so
impacted.
what will happen if the
Suppose this
your current is not
increase as a
increasing at the
2x
same
amount, this
amount,
power.
your
The
voltage will
current,
get
suppose I
impacted.
increase
Suppose
x,
this
so voltage should also
increase as a
increase
2x
x
amount,
at
this power.
amount to meet
The
this
current,
2x. Okay,
suppose
if
I
the power
increase x, so
this power
voltage should
factor is
also
unity.
increase x
Okay,
at amount
if
to
that
meet
same
this
happen with
2x.
this
Okay,
Q.
if the power
Okay, so what
this
I
power
am saying
factor is
that I
unity.
am maintaining this
Okay,
current as a
if that
constant,
same
varying
happen
this
with this
current
Q.
according to this
Okay,
P.
so
If
what
the
I
P
am
is
saying
2x,
that
the
I am
I
maintaining
should
this current
also
as a
move in
constant,
the
varying
2x
this current
2x
according to
dimension
this
with
P.
IRMS
If
as
the
a
P is
constant,
2x,
VRMS
the
as a
I
constant.
should
Okay,
also move
so
in the
that kind of system is
2x dimension
given
with
in the
IRMS
second,
as a
that is the grid
VRMS
feeding
as a
mode.
constant.
So grid
Okay,
feeding means
so
you
that
should
kind of
take the
system
power
is
and the
given
reactive
in the
power what is
second, that is the
needed
grid
based
feeding
upon
mode.
the reference.
So
You
grid
should
feeding
generate
means
that
you
amount
should
of
take the
current.
power
Okay,
and the reactive power of
because
what is
ultimately
needed
you need
based
to
upon the
give
reference.
this
You
power
should
to the
generate
grid
that
itself,
amount of
grid
current.
itself when
Okay,
it is in demanding
because
condition.
ultimately you need
So
to
what
give
I
this
have
power
explained
to
in
the
the
grid
point is
itself
that
when
the
it is
grid
in demanding
supporting voltage
condition.
source. Grid
So
supporting voltage
what
source is
I have
that
explained in
Q
the
and
third
P I am
point is
taking
such
as a
that the
reference.
grid
Why?
supporting voltage
Because
source,
I am
grid
supporting the
supporting
grid.
voltage
I am
source is such
supporting the
that
grid
Q and
with a
P I
P
am
and the
taking as the
Q.
reference.
But
Why?
I am
Because I am
also it says
supporting
that
the
the
grid.
voltage and
I am
frequency
supporting
should
the
be
grid
constant
with
because
a
I am the
P
grid
and the Q.
supporting mode.
But
But
I am
it
also
should
is such
maintain
that the
the
voltage and
and the
frequency should
frequency
be
at the same
constant because I
level.
am the grid
Means
supporting
it
mode,
should be in
but
synchronism
it
with
should
this
maintain
grid.
the
This
voltage and the
microgrid
frequency at a
should be
same
in
level.
synchronism with the grid.
Means it should be in
Suppose I am
synchronism with
maintaining
this
this
grid.
as a
This
constant
macro
current
grid
source, this
should be
current
in
source, grid
synchronism with the
supporting
grid.
current source, any
Suppose
amount of
I am
current I can
maintaining this
deliver.
as a
Okay,
constant
so
current
this
source,
kind
this
of
current
system
source,
is
grid supporting
depicted
current
as a
source,
V
any
output
amount
and
of current
frequency I
I
am
can
taking as
deliver. Okay,
a
so this
variable,
kind of
and
system
from
is
that I am
depicted
generating
as a
P and
V
a Q.
output and
Okay,
frequency I have
this
taken as a
group concept I will explain in the
variable,
further
and from
slides.
that I
Okay,
am generating P and a
I
Q.
hope I have
Okay,
explained this
this
your
group
concept.
concept I will explain in the further slides. Okay,
So,
I hope I have
moving to
explained
this
this
further
your concept.
slides, which
Tanvi.
is most important.
So
This is
so
the
moving to this
major,
further
more
slides,
advanced
which is most
architecture if you
important.
see from here.
This is
I
the
have put it
major, more advanced
deliberately
architecture
for
if you
making
see from
understand
here.
that. Suppose
This
you
I
have a
have
certain DC
put
source.
it
Suppose DC is generating
deliberately
through,
for
suppose,
making you understand
through
that.
solar PV you are
Suppose you
generating
have a
certain
certain DC
voltage,
source.
and which is
Suppose
constant.
DC is
Okay, you
generating
are
through
maintaining the
suppose
voltage as a
through
constant
solar
level through
PV you
some
are generating
capacitor
certain
and
DC
resistor.
voltage, and which is
So
constant.
this is
Okay, you
connected
are
to some
maintaining the
inverter.
voltage as
The
a
DC
constant
is
level through
transferred to
some
this
capacitor
AC to
and
the grid.
itself.
This is the grid
So this is
and this is
connected
the
to some
inverter
inverter.
here.
This
This
DC
is
is
the inverter.
transferred to
Okay.
this AC through the
So in
grid.
between,
This is
if
the
you see
grid
this,
and
this
this is the
L1 is
inverter
connected
here.
and in
This is the
between C
inverter.
is connected
Okay.
and your
So in
grid
between,
side
if you
certain
see
L2 is
this
connected.
L1 is
This is a
connected
kind
and
of
in
filter.
between C is
This
connected
is a
and
kind of
your
filter.
grid side
Filter
certain
is
L2
such
is
that
connected.
it will
This is
generate,
a kind of
suppose
filter.
you will not
This
after
is a kind
inverter,
of
what you
filter.
get? You get this
Filter
kind
is
of
such that
kind
it
of
will
waveform inside
generate,
that,
suppose
and
you
this
will
kind of
not
waveform.
after the
From that
inverter
you
what
have
you
to
get,
generate this
you get
AC
this
source.
kind of waveform, kind
For
of
that you
waveform is
need
such that,
certain filters
and this kind of
filters
waveform. From that
LC
you have to
filters,
generate this
LCL
AC
filters,
source.
LLC
For
filters,
that you
certain
need certain
topologies are
filters.
there. Okay.
Filters.
So
LC
this kind of
filters,
structure
LCL
L1,
filters,
L2, two
LLC
kind of
filters,
voltages
constant
and one capacitor
topologies are
bank
there.
is there
Okay.
to damp out
So
the
this
what
kind of
kind of
structure
this
L1,
filter out
L2,
this
two kind of
harmonics.
voltages
Okay.
and one capacitor
So
bank
if
is
you
there
see
to
here,
damp out the
I
what
am
kind
taking
of
the
this
this
filter
current
out
as
this
a reference from the
harmonics.
grid
Okay.
side, and I am
So if
feeding
you
to
see
this
here,
H12,
I am taking
HI2,
the this
and I am
current as a
converting to
reference
some
from
other
the grid side,
reference.
and I am
From
feeding
that
to
I am
this
controlling this
H12,
I2,
HI2,
this current,
and I
alpha
am
beta in
converting
that
to some
between,
other
if you
reference.
understand this
From
path
that I am
transformation.
controlling this
ABC,
I2, this current
one
alpha
dimension
beta
is
in
there,
the different,
second is
if
the
you
DQ
understand
frame,
this spark
suppose the
transformation.
alpha beta is not
ABC,
frame is there.
one
You
dimension
can
is there,
understand
second
from
is the
this
DQ
further
frame,
slide.
suppose the alpha
So
beta is
this
not
ABC
frame
to
is
alpha
there.
beta
You
frame it is
can
converted,
understand
and
from
at
this
that
further
particular
slides.
time this current is
So
being
this ABC
controlled
to alpha
based
beta
upon the
frame it is
what
converted,
this
and at that
capacitor
particular
current
time
what
this
is flowing.
current is being
Okay, to filter.
controlled
From
based upon
that
the
this
what
PWM
this
modulator, this
capacitor current
PWM
what is going,
generated of this
okay, to filter out. From
switches
that
what
this
is being
PWM
installed in
modulator,
the
this
inverter itself.
PWM
So what
generated
is the
of
happening
this
that
switches what
voltage
is
is taking
being
as the
installed
reference.
in the
If you see
inverter
what I
itself.
am drawing,
So what
here
is the
the
happening
voltage
that
of the grid is taken as a reference.
voltage is taking at the
In the
reference.
second what
If
I
you
am
see what I am
highlighting,
drawing,
the current
here the
of
voltage
the
of the
going
grid is
into
taken
this
as a
inverter,
reference.
grid,
In the second
it
what
is
I am
being
highlighting, the
monitored.
current of the
Third is
what is
that
going
the
into this
current which is
inverter
being filtered,
grid, it is
which is
being
going to this
monitored.
capacitor
Third is such
bank
that
is
the
also
current
being
which is
monitored
being
based upon the all
filtered, which is
three
going to
monitoring
this
systems, one
capacitor
PWM
bank
generator
is
which
also
going
being
to this
monitored
inverter.
based upon the
Switches.
all three
Okay.
monitoring systems, one
Moving to this
PWM
further
generator
slide, if
which
you
is
see
going to
this,
this inverter.
this LCL
Switches.
type I have considered,
Okay.
this grid connected inverter.
Moving to this further
This is
slide,
the
if you see
I2,
this,
if you see this
this
I2 star
LCL
and
type I
I2
have
beta
considered,
star.
this grid
This is
connected
similar to
inverter.
that ABC
This is
to
the
alpha
I2,
beta
if you
frame
see
it
this
is being
I2 star and
converted.
I2
Okay.
beta star.
You
This
can
is
take the
similar
help
to
of
this
the
ABC
online
to
material,
alpha
okay,
beta frame
online
it is getting
material for
converted.
understanding
Okay.
this part
You can take the
transformation,
help of the
Fox
online
transformation,
material, okay,
how this
online
ABC
material
to alpha
for
beta
understanding
frame
this
is being
spark
converted. If you are
transformation,
using
Fox
MATLAB, there
transformation,
is a certain blocks are there
how this
which
ABC to
directly
alpha
convert
beta
this
Q
alpha
frame is
beta
being
to
converted. If
ABC
you are
or
using
ABC to
MATLAb,
alpha
there is
beta.
a certain blocks are
So
there
for
which
controlling
directly
this
convert
alpha
this
beta, it
alpha
is
beta
very
to
easy
ABC or
because
ABC
alpha
to
is a
alpha beta.
coupled
Okay.
term of the ABC
So for
current,
controlling this
and beta
alpha
is
beta,
also
it is
one of the
being very
coupled
easy
terms of
because
the
alpha is a
ABC.
coupled
You
term of the
don't have
ABC
to
currents, and
individually
beta is
control
also
the
one of the
ABC
coupled
phases,
terms of this
and you only
ABC.
control this
You
alpha
don't
beta, you
have
can
to
control the overall
individually
system what
control
you
the
want.
ABC
Same with
phases,
GIS,
and you only control
and
this alpha
this
beta, you can
certain I have
control the
shown you,
overall
this is
system what
control
you want.
architecture. This is in
Same
the
this
alpha beta
GIX,
frame.
and
So there
this
is a
certain
certain
I have
control
shown you, this
architecture
is
inside
control
of that.
architecture, this
From
is in
that
the
I am
alpha beta
controlling this I2
frame.
alpha, I'm generating
So there
I2
is a
alpha,
certain
I2
control
beta by
architecture
taking the
inside
I2
of
star
that.
and I2
From
beta
that
star
I am
as a
controlling
reference.
this I2
Okay.
alpha, I am generating I2
So this is
alpha,
the main
I2 beta
inside
by
of the
taking the
architecture.
I2
Don't
star
go
and
in the
I2
depth
beta star
because
as a
that is not
reference. Okay.
help you for
So this
solving
is
the
the main
assignment.
inside
If you
of the
want to do
architecture.
research
Don't go in
also,
the
I will
depth
give you
because that is
supporting
not
documents for that.
help you for
Same
solving
with
the
this,
assignments. If you want to
you
do
see here
research
in the
also, I
DQ
will
frame,
give you supporting documents for that.
DQ frame also.
Same with
So
this,
there are two frames are there,
if you see
which
here in the
is
DQ
very
frame,
helpful for controlling this reactive
DQ
power
frame
and
also. So
active
there
power,
are
this
two
alpha
frames are
beta
there,
and DQ frame.
which is
The
very
DQ
helpful
frame,
for
if you
controlling
see,
this
there are
reactive
more
power and the
complex architecture
active power,
inside of
this
that.
alpha beta
And
and the
you have
DQ
this
frame.
coupled
In the
terms are
DQ
there.
frame, if you
Suppose
see, there
this
are more
omega
complex
L2 term
architecture
is there,
inside
what I
of
am
that,
highlighting. It
and
takes
you
the
have a
I2 as a
coupled
reference
terms are
and
there.
giving
Suppose
inside of
this
this
omega
I2D
L2
and
term is
taking
there, what I am
I2D
highlighting,
into
it
this
taking the
I2
I2 as a
okay.
reference and
From
giving
that it is
inside of
generating
this
I2D and
I2D
I2Q
and
by
taking
taking I2
I2D
star D
into
and
this
I2Q
I2Q.
star as
Okay,
a reference.
from that
Okay.
it is generating
Don't
I2D
go
and
in depth. this
q
is
by
for
taking
just
I2
for the
star d and I2
illustration.
q
Okay,
star as a reference.
so
Okay,
coming to this
don't go in
main
depth. This is for just
concept
for the
what I have
illustration.
explained in the
Okay,
further, that is in
So
the
coming to
more
this
advanced
main
architecture. That is the
concept,
first is the
what I
grid
have
feeding
explained
mode.
in the further, that is
Grid feeding or
in the
grid following,
more
that is
advanced
the both are
architecture.
the
That
same.
is the
Okay,
first is the grid feeding
following the
mode.
grid or feeding the grid.
Grid
Okay,
feeding
what I
or
am
grid
showing you here
following.
is
That
that
is the both are the same.
suppose you have a
Okay,
certain DC
following
generation
the
source
grid or feeding the grid.
and you
Okay,
maintaining
what I
have
am
a
showing you
certain
here is
capacitor
that
bank which is maintaining
suppose
the
you have a
voltage as a
certain
constant,
DC generating
then you have
source
a one
and
inverter
you maintaining
and you
have a
have one
certain
LC
capacitor
filter
bank
for
which is maintaining the voltage as a
for
constant. Then you have a
eliminating the
one inverter
harmonics inside
and
of
you have one LC
inverter
filter
output.
for
And there you have a point
for
of common coupling, this PC
eliminating the
point of
harmonics
common coupling.
inside of
At that
inverter
point this
output.
microgrid
And there
is
you have a
connected.
point
Okay,
of common coupling, this
so what
PC
I'm
point
doing
of
here
common
in the grid
coupling.
feeding
At
mode is
that point
that
this
I'm taking
microgrid
this
is
voltage which is
connected.
connected at
Okay,
this point of
so what
coupling
I'm
as a
doing here in the
reference,
grid feeding
and
mode is
from
such that
that
I'm taking this
I'm
voltage which
taking
is
one P
connected at
reference
this
and a
point
Q
of
reference,
coupling as a
what I
reference,
have to
and
generate,
from that
and after that
I'm
I'm
taking one
generating one
P
I
reference and the
reference,
Q reference,
and with that
what
I
I have
reference
to
is also
generate,
taking one
and
input
after
from
that I'm
before this
generating one
LC
I
filter
reference,
output,
and
and
with
from
that
that
I
I am
reference is
feeding to
also
certain
taking one
controller. Suppose
input
I am
from
feeding to
before
this
this
PI
LC
controller.
filter
Based
output,
upon that
and
I am
from
generating
that
this
I'm feeding
PWM
to
signal.
certain controller.
What is
Suppose I am
happening
feeding
here
to
is
this
that
PI controller.
P
Based
reference
upon
and
that
Q
I am
reference you have
generating
to
this
generate,
PWM
because
signal.
from where
What is happening
it
here
is
is
coming
that
from the grid.
P
Because why?
reference and Q
Because you have
reference
to
you have to
feed to the
generate,
grid.
because from where
Same,
it is
if you are
coming, it
feeding
is
to the
coming
grid,
from
you
the
should
grid.
take the
Because
P
why?
reference and the
Because you
Q
have to
reference.
feed to
If
the
you are in the
grid.
grid following, you should
Same,
take
if
the
you are
voltage
feeding
and
to
the
the grid, you
frequency as
should
a
take the
reference. Okay.
P reference and the
So
Q
what I have
reference.
written that
If you are
grid
in the
feeding or
grid
the grid
following, you
following
should take the
power
voltage and the
converters
frequency
are
as the
mainly
reference.
designed to
Okay.
deliver power
So
to
what I have written that
energize the
grid
grid.
feeding or the grid
They
following
can be
power
represented as an
converters are
ideal
mainly
current
designed to
source
deliver
connected
power to
in the
an
grid in
energized
parallel to
grid.
the with the high
They can
impedance.
be represented
Okay.
as an ideal current
Same way.
source
Why? Because the
connected in
P
the
and the
grid
Q
is
reference are
parallel to the
taken.
with the
I
high
am
impedance.
maintaining the voltage as a
Okay.
constant because the P
Same
is
way.
equal to
Why?
V
Because the
RMS I
P and
RMS
the
cos
Q
phi,
reference I have
and this
taken,
I
I
will
am
vary
maintaining
as
the voltage
compared
as
to
a
this P.
constant because the
Okay,
P is equal to V
as
RMS
compared
I
to this
RMS
P
cos phi,
through this
and this
current
I
source.
will vary
Okay,
as compared
but I
to
am
this
maintaining
P.
this voltage as a
Okay,
constant through
as
this
compared to
point
this
of
P
common coupling
through
voltage
this
difference.
current
Okay.
source. Okay,
So these
but I am
power
maintaining this
converters are
voltage as a
suitable to
constant
operate
through
in
this point
parallel
of
with the
common
other
coupling voltage
feeding power
reference.
converter in
Okay,
the grid connected
so
mode,
this
because
power
you can
converters are
connect the
suitable to
multiple
operate
units
in
in the
parallel
parallel.
with
What
the
it
other
is has been
feeding
shown
power
earlier.
converter in the grid
In this
connected mode,
point, you
because
can
you
connect the
can connect the
multiple
multiple
times
units
of
in the
multiple
parallel.
number
What
of
it is
microgrids.
have been shown in the
And
here.
P and
At
Q
this
star is
point,
taken
you
as
can
the
connect the
reference for
multiple
generating
times
this
of
what
multiple number
amount
of
of current
microgrids.
it should deliver.
And
Okay.
P and Q star is taken as the
So
reference for
this is the
generating this what
most
amount
important. The
of
voltage and
current
the
it should
frequency of the
deliver.
microgrid
Okay,
is maintained as a
so
constant level by
this
taking
is the
certain
most
reference.
important.
Okay.
The voltage and the
So
frequency of
coming
the
to the
microgrid
second point,
is maintained
that
as
is
a
the
constant
grid
level
feeding
by taking
structure.
certain
Grid
reference.
feeding,
Okay,
because grid
so
forming
coming
or
to this
grid
second
feeding,
point,
this is the
that
same.
is
Grid
the grid
forming
feeding structure.
or grid
Grid
feeding,
feeding, because grid forming or
both
grid
are the
feeding,
same.
this is the
And
same.
in
Grid
that also you
forming
have a two
or
architectures.
grid
One is
feeding,
the passive architecture
both are
and
the
second
same.
is the one is the
And in
active
that also you have
architecture.
a
Okay.
two architecture.
If
One
you
is the
see, this is the
passive
example of the
architecture
passive
and second
architecture.
is the
Why?
one is the
Because
active
if you see this,
architecture.
you have a
Okay,
solar PV
if you
generation is
see,
there,
this is the example
which
of
is
the passive
connected to one
architecture. Why?
capacitor
Because if you see
and which
this,
is
you have
not
a
connected
solar
to
PV
any DC to
generation is
DC
there,
converter.
which is
There is a
connected to
no
one
concept of DC to
capacitor
DC converter
and
here.
which is not
This is
connected to
directly
any DC
connected
to
to
DC
DC to AC
converter.
converter and
There
being
is a
feeding
no
to the grid.
concept of DC to
Okay.
DC converter
So this
here.
is the passive
This is
generation
directly
type.
connected to
Okay.
DC to AC
Here the
converter and then feeding to
voltage
the grid.
after this
Okay, so
capacitor is
this is the
taken as a
passive
reference,
generating type.
and for
Okay, here
maintaining
the
this MPPT,
voltage
MPPT
after
unit
this
is maintained.
capacitor is
Then
taken
through
as the
DC bus
reference,
control, this P
and for
reference is
maintaining this
generated.
MPPT,
Okay. P
MPPT
reference is
unit is
generated means
maintained. Then
what
through
amount
DC
of
bus
power you
control,
can
this P
support to the
reference is
grid based
generated.
upon your
Okay,
solar
P
PV
reference is
generation.
generated
Okay.
means
P
what
underscore.
amount of power you can
So
support to
this
the
is
grid
the
based
same with
upon
this,
your
the
solar
what
PV
amount of
generation.
generated,
okay,
and
P
based
and the
upon
Q.
that VAC and
So this is the same
IABC
with this, the what
converted into
amount of
DQ frame,
generated,
then it
and
is fed
based
into
upon
this
that
power
VAC and
controller. Then it is
IABC
subtracted with the
converted into
reference
DQ
which is
frame, then
generated
it
from
is
the
fed
P
into
and
this
the Q,
power controller,
and then
then
fed
it
into
is
this PI controller. Based
subtracted with
upon
the
that,
reference which is generated from
again
the
DQ
P and
frame
the
is
Q,
converted to
and
ABC,
then
then
fed
it
it
is
to this
going
PI
to this
controller. Based
PWM
upon that,
controller,
again DQ frame is converted to
PWM
ABC,
signal
then it is
generator, then
going
it
to this
feed to
PWM
this
controller,
inverter, then it will
controller
generate
PWM
that
signal
amount of
generator,
power
then
which is
it
needed.
feed to
Coming to this other
this inverter,
architecture,
then
this is
it
the
will
PQ mode
generate that
architecture,
amount of
which is
power
active
which is
mode.
needed.
Here if you see,
Coming
you
to
have
this
a
other
DC to DC
architecture, this
converter
is the
also.
PQ mode
In that
architecture,
you
which is
don't need
active mode.
to the,
Here if you see,
you
you have a
don't need to
DC to DC
generate this
converter
P
also.
reference. You
In
have to
that,
generate
you
this P
don't need
reference at a
to
constant
you
because
don't need
this
to
voltage
generate
which is
this
coming
P
from the
reference.
DC
You
DC
have to
converter
generate
is
this
the
P reference
maintained
at a
at a certain
constant
level. You
because
don't need
this voltage which is coming from
MPPT
the DC to
control
DC
here.
converter
In
is
the
the
last
maintained
passive
at a
wave
certain
control, you
level.
need the
You
MPPT
don't
reference.
need a
Here you don't need
MPPT
any
control here.
MPPT reference.
In the last
So
passive
DC
waves
bus
control, you
control
need the
means P
MPPT
reference is
reference.
generated
Here
and
you
the
don't
other
need any
architecture remains the
MPPT
same.
reference. So
Only
DC
difference
bus
is that
control, there is
here the
P
DC to
reference is
DC converter is
generated
there.
and the other
In the last
architecture remains
architecture
the
there
same.
is no concept of DC to
Only
DC
difference
converter.
is that
Okay.
here the DC to DC converter
So
is there.
coming to this
In the last
last
architecture, there is no
architecture, that
concept
is
of
the
DC DC generator.
second
Okay.
last, that is the grid forming.
So coming
What
to
I
this
have already
last
explained, that
architecture,
grid
that is
feeding
the
or the grid following.
second last, that is the grid forming. What I
This is
have
the grid
already
forming.
explained, that grid
So
feeding or
if you
the
see
grid
in the
following,
right side, what I am highlighting,
grid
there
following,
is no grid.
and this is the grid forming.
Okay.
Suppose if you
It is
see in the
the
right side, what I am
situation.
highlighting, there is no grid.
So from where you will
Okay.
generate this
So
230
it is
volt
in
and the 50
the
amp.
islanded
In the
situation.
grid following, you are already
So
connected to the
from
grid.
where you will
And
generate
from
this
taking the
230
grid
volt and the
reference,
50
the
amp.
230
In the
volt and
grid
50
following,
amp, you are
you are
generating
already
the
connected
reference
to
of
the
the
grid. And from
Here,
taking the
how
grid
you will
reference,
generate
that
this
230
VABC
volt and
reference?
50 amp, you are generating your
what is
reference of
that?
the voltage.
You have LC
Here,
filter.
how you will
And
generate
after
this
LC
VABC
AC
reference?
filter, you have this
Here, what
PCC.
is that?
This is the PCC.
You have
And
LC
taking the
filter,
PCC point
and the
of
after
this
LC AC
and
filter,
checking
you
the
have
voltage.
this
This is the
PCC. This is the PCC.
PLL is
I'm
such
taking
that
the
point
PCC
of
point of
this
this
phase lock loop
and
for
checking the
generating
voltage.
theta reference.
This is the
Theta
PLL.
reference
PLL is
by
such that
taking
point of this
omega
phase
as a
lock loop
variable.
for generating theta reference.
You can
Theta
also
reference by
take the
taking
help of
the
certain
this omega
lectures
as
also
a variable.
for understanding
Okay.
this PLL.
You
PLL
can
is
also
there to generate
take the
this
help
theta,
of certain
theta
lectures
as a
also
reference.
for
Okay.
understanding this
This
PLL.
theta reference
PLL
is
is
being
there to generate this
generated,
theta.
taken as the
Theta
reference.
as a
Then the
reference.
current,
Okay.
which is
This
after
theta
this
reference is being
taken as a
generated,
reference for
taken as the
generating
reference.
ID and
Then
IQ.
the current which is
Same
after
here,
this
VABC
is taken as
multiplied
reference
with
for
certain
generating
gain
ID and
and
IQ.
converted with reference to
Same
P
here,
and the Q,
VABC is
what
taken
will
as
be
reference,
generated,
multiplied with
ID
certain
star and
gain
ID
and
Q star.
converted with reference
Then
to
it is
P and the
multiplied
Q
to the
what
L
should be
omega term.
generated,
Why? Because
ID
the
star and
voltage
ID
is I
Q
times
star.
of XL, that
Then
is
it is
I
multiplied to
multiplied
the
by
L omega term.
L.
Why?
What is
Because
L
the
here?
voltage
You have
is
to
I
consider, you have
times
to
of
find out
XL,
with the
that is
using of
I
this
multiplied
XI
by
R
L
factor.
omega.
Okay.
L, what is
From
L
that
here?
you are
You
generating
have to
UD
consider,
and
you have to find
UQ,
out with the use
and
of this
again
X by
converting
R
back
factor.
to
Okay.
DQ to ABC.
From that
then
you are
feeding
generating
to
UD
this
and the
PWM
UQ
converter.
and again
Okay.
converting
So
back
this is
to
a kind
DQ
of
to
grid forming
ABC.
structure
Then you
which
are
is
feeding
very
to this
important in
PWM
the islander
converter.
situation.
Okay.
Okay.
So this is a kind of grid
This is
forming
the
structure which is
practical
very
example of the
important
grid
in the
forming
islander
UPS
situation.
itself.
Okay.
What you use. So
This is
the power
the
supply is
practical
on, then
example of
UPS
the grid
continues to
forming,
supply
your
the power
UPS
to your
itself.
home.
What you use,
Suppose you
if
are
the power
connected to
supply
this
is gone, then UPS continues to supply
PC,
the power
this
to your home,
personal computer.
your
So at
suppose you are
that
connected
also
to
you
this
generate this 230 volt and 50 hertz
PC,
at,
this
for certain
personal
duration.
computer. So at
standby
that also
UPS
you
is a
generate
form
this
of
230
grid
volt and
forming
50
power
hertz at
converter. Okay.
for certain
In the
duration.
microgrid, the
So
AC
standby
voltage generated
UPS
by
is
the
a
grid
form
forming
of
power
this grid
converter will be
forming power
used as a
converter.
reference
Okay.
for the rest of the
In
grid
the
feeding power
microgrid, the AC
converter.
voltage generated by the grid
So
forming
there are
power connector
multiple,
will be
if there
used
are
as a
multiple
reference for the
connected
rest of the grid
microgrids are
feeding
there.
power
So
converter
one
connected to you.
point of common
So there are
coupling is there.
multiple, if
So
there are
take one
multiple
as a
connected
reference, you can
microgrids are
generate the
there.
power based
So
upon
one
that for the
point of
multiple
common
number of
coupling is there.
inverters.
So
So
take
this is
one as a
suitable for the
reference, you can
island.
generate the power based upon that
So
for the
coming to the
multiple
last
number of
topic, that is the
inverters.
grid supporting.
So this
Grid
is suitable
supporting
for
is
the
such that
electric
you only
operation.
need this P and
So
the
coming
Q
to the last topic,
difference
that is the
reference.
grid supporting.
Difference
Grid
reference
supporting is such that you
what
only
amount
need
of
this
power
P
should be
and the
generated,
Q
what amount of
difference
Q should be
reference.
generated.
Difference reference
Only
is such
that
that
for
what
particular
amount of
point
power
which
should
you
be
need.
generated, what amount
Suppose
of
the
Q should be
100% is
generated.
demand.
Only that
So grid
particular
is
point you
already
should
supplying
need.
70.
Suppose the
and 30 is being
100%
supplied
is
to
demanding.
certain inverter
So
IB.
grid is
Inverter
already
based
supplying
unit.
70,
sources.
and
So
30 is
this
being supplied
30%
through
should
a
be
certain
as a
inverter
support to this
IBRs.
grid.
inverter based
If you
generation
see the
sources.
control architecture
So this
also, here the
30% should be
omega
as a
star and the P
support to this
star
grid.
and the V
If you see
naught
the
star and
control
the Q star
architecture
all are
also,
taken
here
as a
the
reconnect.
omega star and the P
For
star
AC
and the
microgrid, AC
V
microgrid for
naught
the
star and the
supplying
Q
this
star
omega
all are
star,
taken as
P
a
star,
reference.
V star and the Q star.
For AC
And for DC
microgrid,
microgrid, if you take V
for
star,
the
I star
supplying
and
this
V naught
omega
minus
star,
P
P
star, this
star,
is
V
taken
star
as
and
a
the Q
reference.
star.
Okay.
And for DC
Reference
microgrid,
is
if
such
you
that
take V
this
star, I star and V
omega
naught
star
minus
minus
P
P
star,
star
this is
and
taken as the
V star
reference. Okay.
and Q star.
Reference is such
Okay.
that there's
This is kind of
omega
grid
star
supporting.
minus P star and
So
V
coming
star
to this
and Q
topic,
star.
that's
Okay.
inverter based control. How
This
is
is
being
kind of
controlled?
grid supporting.
Suppose you have this
So
V
coming to
input
this
is there and
topic,
certain
that's
V output
inverter
is
based
there
control.
and
How is
some
being
inductive
controlled?
inductance are
Suppose
there.
you
Like
have this
what I
V
have
input
shown you
is
that
there and certain V output is there
after the
and
inverter
some
output,
inductive
if your
inductance
inverter
are
is
there.
giving
Why?
certain output,
What I have shown you that
then you connect certain
after
L
the inverter
C
output,
filter,
if your inverter is
and
giving
after
certain
that
output,
you connect the
then
through
you
the
connect certain
common
L
coupling to
C
the grid.
filter.
Okay.
And
So
after that
this
you
L,
connect the
this
through the
L
count
is one
of
kind of
common coupling to the grid.
this
Okay.
filter kind of thing, and
So
this is the voltage
this
which
L,
is VG,
this L
grid
is
side
one
voltage,
kind of
and this is the inverter
this
voltage.
filter kind
Okay.
of thing, and this is the
So this
voltage
current
which is
which is being
VG,
generated,
grid
if
side
you see
voltage,
the what amount
and
of
this
power
is
is
the
being
inverter
generated,
voltage.
PG
Okay.
is
So this
this V
current
input
which is being
RMS.
generated, if you see
If
the
you
what
three
amount
phase,
of power
3
will be
V input
generated,
V
PG
multiplied by
is
omega L sine
this
delta,
V input
and
RMS.
what Q
If
will be
it is three
generated, Q
phase, 3
generated will
V
be
input V
this V
multiplied
by
by
X
omega L sine
divided by
delta,
this
and
3
what Q
times
will
if
be
you there
generated, Q
this
generated will be
V input
this V
cos
by
delta
X
minus
divided by
this V.
this 3
Okay,
times if you there,
this amount of Q
this
should be
V
generated.
input cos
So this
delta
is a kind of
minus
system is that
this V.
what amount of
Okay.
P and Q
This
should be
amount of Q
generated,
should be generated.
it can be
So
determined
this is a
using this
kind of
L.
system is that
So
what
this
amount of
L
P
is in
and Q
our
should
hand
be generated,
by using
it
this
can be
LC filter
determined
or
using this L.
LLC filter,
So
LCL filter.
this L is
You
in
can
our hand.
operate that
By
what
using this
amount of
LC
P and Q
filter
should
or
be taken.
LLC filter,
Okay.
LCL filter,
So
you
that
can
is the main concept.
operate
So
that
coming
what
to
amount
this
of P and Q should be
islanded
taken
based
out.
situation, I'll
Okay.
be considering that.
So that is
I'll
the main
explain you
concept. So
that
coming
also
to
in
this
that. This is the
islanded
PLL
based situation,
for
I will be
generating this theta
considering that.
reference.
I have
And V
explained
star is such
that
that
also
taking the
in there.
voltage the
This is the
reference
PLL for
at this
generating this
VABC,
theta reference,
and the
and V star
voltage
is
what
such
you
that
want to
taking the
generate. Suppose
voltage
you
the
want to
reference
generate 230,
for,
you should
at this
give the reference
VABC,
based upon
and
that.
the voltage what you
And
want to
this
generate. Suppose you
inverter
want to
will
generate
operate
230, you
like
should
that only.
give the reference
Okay.
based upon
Up
that,
to this point, if you have
and this inverter will
last point
operate
in the
like
previous
that only.
slide, last
Okay.
point,
Up to this point, if you have last point in the previous
last
slide,
point, this point
last
I think.
point,
So this AC microgrid, if you are seeing here, what
last
reference
point,
you
this
should
point
take?
I
You
think.
should take the
So
reference
this
as
AC
omega
microgrid,
star
if
and
you
the
are
P star,
seeing here,
omega
what
star
reference you
minus
should
P
take?
star,
You should
and
take
here
the
V
reference
star
as omega
minus Q
star and the
star.
P
Why?
star,
Because the
omega
Q
star
is
minus P
strongly
star,
coupled
and
with
here
the
the V
voltage,
star
and the P
minus Q
is
star.
strongly
Why?
coupled with this
Because the
delta.
Q is
delta.
strongly
And how
coupled
you
with the
generate this
voltage,
delta?
and the P
Omega
is strongly
d delta
coupled
by
with this
dt,
delta.
and delta
delta.
is the integration
And
of
how
this
you
omega
generate
dt.
this delta?
So if
Omega
you use
is
the
d
integrator
delta by
here,
dt,
then you will
and
get
delta is the
So
integration of
from
this
where
omega
the
dt.
which
So
is
if you use
strongly
the
coupled, from
integrator
that you
here,
should take the
then you will
reference
get
based
delta.
upon that.
So
For the
from
DC
where the
microgrid, there
which
is no
the is
concept of
strongly
frequency.
coupled, from
So
that you
what
should
you
take
will
the
take the
reference
reference?
based upon
You
that.
will take the
For
P
the
star
DC
minus V
microgrid,
star,
there is no
then
concept of
multiplied with the I
frequency.
star,
So what
then
you will
take
take
the
the
difference.
reference?
Okay,
You will take the P
that
star
reference
minus
will
V
be
star,
will
then
be good.
multiplied with the I
Okay.
star, then
So
take the
that kind
difference.
of architecture
Okay.
is there. Okay.
That reference should be will go. Okay.
So
So that
coming
kind
to
of architecture
the
is
further
there.
slides,
Okay.
further slides is that this microgrid ancillary services
So
is such that
coming
there
to
are
the
multiple
further slides,
advantages
is
of
that this
For that,
microgrid
this
ancillary
microgrid is being
services is
used.
such that
Frequency
there are
control
multiple
support based upon this
advantages
power
of that.
difference,
For that, this
reduction
microgrid
in
is
the
being
grid
used.
losses,
Frequency control support
improvement in the
based
power
upon
quality,
this
voltage dips,
power
and the
difference.
support itself,
Reduction in
voltage
the
control,
grid losses,
congestion management.
improvement the power
And
quality,
in the
voltage dips
idling, this
from this
black
support
start
itself,
when the
voltage
all
control,
your
this
system
congestion
is in
management.
down condition,
And in the
what
idle
you
ending,
have to
this black
restart the
start when
system.
the
This
all the
isolated
your
mode, this
system is in
microgrid
down
can
condition.
play a major role,
You have to
and the grid
restart the
forming
system.
operation
This
itself, that
isolated
forming
mode,
a
this microgrid
self
can
grid
play
for
a major
in
role,
this using
and
this
the grid
microgrid.
forming operation
So
itself,
main
that
thing is
forming a
that what is being controlled,
self grid for
what I have
this
already
using
told
this
you, that
microgrid. So
power I have
main thing
taken
is
one of the
that what
reference,
is being
Q
controlled.
star I have taken one of the
What I have
reference,
already
V
told you
star
that
also I have taken one of the
power I
reference,
have
and
taken one of
omega
the
star
reference,
also
Q star I have
taken one
taken
of the
one of the
reference.
reference, V star
So
also I have
in the
taken one of the
grid
reference,
forming,
and
in the
omega
grid,
star
if the grid is
also
being formed,
taken one
so
of the
P star
reference.
and the Q star is being taken as
So
the
in the
reference. If the
grid
grid
forming,
following is
with the
there,
grid, if
V
the
star
grid
and the
is being
omega star
formed,
is taken as the
so P
reference.
star and the Q
So
star is being
key
taken as the
controllable
reference. If the
variables in
grid
the
following is
microgrid is
there,
such that
V star
V
and the
star,
omega star is taken as the reference.
omega star,
So
P star
key
and the Q
controllable
star.
variables
These
in
are
the
the
microgrid is
controllable
such that
variables
V
inside of
star,
it.
omega star,
So if you
P
see
star
that
and
this
the
is the
Q star.
hierarchical
These are the
control is there.
controllable
I have
variables
shown you.
inside of them.
This
So
is the
if you
most
see that
important
this is the
architecture from
hierarchical
where the
control is
controls
there,
will
I have
start and
shown you.
from where the control is propagated.
This is the
So
most
if you see
important
the
architecture
microgrid
from where
operating
the
from
control
the
should start and
upper
from
point
where
of
the
view,
control is
you have
propagated.
a distribution
So if you
network,
see
this is
the
main grid.
microgrid
Main grid
operation
is there,
from the
which is
upper
connected
point
to
of
a
view,
global
you
controller.
have a
Global
distribution
controllers
network. This is
take the
main
input
grid.
from the
Main grid is
multiple
there, which
microgrids.
is connected
This is
to
the
a global
MG1, this
controller.
microgrid 1.
Global controllers
This is the
take the input
MG2
from the
microgrid 2.
multiple
This
microgrids.
and this
This
is the
is the
MG1. This is
MG1,
a
this
n number of
microgrid 1.
microgrids.
This is a
And this
MG2
all
microgrid 2.
microgrids are
It is,
connected to a
and this is
global
a
controller,
MG1. This is a n
global
number of
central
microgrids.
controller, which is also
And this
connected
all
to this
microgrids are
distributed
connected
network,
to
that is
a
main grid.
global
Okay.
controller, global
And
central
inside of
controller,
this
which is also
microgrid
connected to
control,
this
you have a
distributed
certain
network, that is main
hierarchy
grid.
also.
Okay.
First, local
And
control.
inside of
Second,
this
secondary
macro
control.
grid
Third is
control,
the
you have
control
a
and
certain
emergency
hierarchy
control.
also. First,
This we will
local control.
explain. I will
Second,
explain in the
secondary
further
control. Third
slides
is the
also,
control and
that
emergency
what
control.
kind of how this is
This we will
being
explain.
tested
I
also,
will explain in the
how
further
is this secondary
slides also,
control, how this is local
that what
control.
kind of how
And if you
this
see
is
in the
being
right side
tested,
image,
that
you have this
how is
local
this
control.
secondary
If you
control,
see,
how this is
this
local
is the
control.
micro turbine
And
or
if you
battery
see
is
in the
there.
right side image,
This
you
whole
have this
structure,
local
this
control.
is the
If you see,
generating source,
this is the micro
which
turbine
is
or battery
connected
is
to a
there.
DC bus bar.
This whole
If you see
structure,
here,
this
the
is
AC
the
bus bar,
generating
and
source,
this AC is
which
connected
is
directly to
connected
this
to a DC
distribution
bus bar.
network. Okay.
If you see here,
So
a
this
AC
is
bus
the
bar,
local control.
and this
Local
AC
control
is
is there.
connected directly
If
to
you
this
see this
distribution
MC,
network.
LC,
Okay.
MC, LC is there.
So this is the local control. Local
This
control is there. If you
control
see
is
this
there. This
MC,
medium
LC, MC,
control,
LC
LC
is there.
control is
This
there. So this kind of
this
control is there, which is
control
already
is there.
connected to
This
one bus
medium
bar,
control,
and
LC
that bus bar
control
is
is there.
connected to one
So
CB,
this
that
kind
is
of
point
control
of
is
common
there, which
coupling,
is already
and this is
connected to one
connected
bus
to AC
bar,
bus bar.
and that
If
bus
you
bar
see
is
that,
connected to
this
one
is the
CB, that is point of
secondary
common
control.
coupling,
This is the
and this
secondary
is
control,
connected to AC bus bar.
and lower
If you
portion
see
is the
that,
primary
this
control,
is the
which take the
secondary
input from
control.
this
This
secondary
is the
control
secondary
itself.
control,
And
and
then
lower
you
portion is the
have a
primary
third
control,
part, that is
which
the
take the
central
input from
and
this
emergency
secondary
control.
control itself.
You have a central and
And
emergency
then
control.
you have a
This
third
is the
part, that
main
is the
architecture. If you
central
see this
and
green
emergency
line,
control.
this is
You have
the
a central and
main
emergency control.
giving
This is the
output of
main
this
architecture.
emergency
If you see
system
these
controller.
green lines,
It is
this is
connected
the
to point
this
of
is the
common
main
coupling to this distribution
giving
network,
output of this
and you
emergency
have
and
one
central
DNO,
controller.
distributed
It is connected
network
to point of
operator
common
also,
coupling to this
which take the
distribution network,
responsibility
and
to
you have
managing
one
operation
DNO,
of this medium
distributed
voltage
network
and
operator
low voltage
also,
areas,
which
okay,
take the
where this
responsibility
microgrid
to
generation
managing
happens.
operation of
What
this
happens?
medium voltage
This is
and
the
low
microgrid
voltage
central
areas,
controller,
okay,
what I have
where this
explained you,
microgrid
and
generation
this
exists.
microgrid
What
central
happens?
controller is
This
connected
is
to
the
all the
microgrid
microgrids,
central
and
controller,
inside of
what
the
I have
microgrid you have
explained
a
you,
multiple
and this
control, that is
microgrid
local
central
control,
controller is
secondary
connected to
control,
all
and
the
central and
microgrid,
emergency control.
and inside of the
Okay.
microgrid you have a multiple
So
control, that
coming
is
to
local
the
control,
further
secondary
slide,
control, and
this is
central
the
and
loop
emergency
based
control.
control coming
Okay.
advantages.
So coming to
So
the
this is the
further
one
slide,
example.
this is the
You
droop
don't
based
need to
control
solve this
coming
question. I'll
advantages.
just put it
So
just
this
for
is the one example.
making you understand
You don't
about
need to
this
solve this
droop
question.
kind
I'm
of
just
concept.
put it just for
Droop concept.
this
So
making
if
you
you read
understand
this
about
question,
this
if you read the
droop kind of
question,
concept.
what you will understand that
Droop concept.
a
So if
single
you
50
read this
hertz
question,
synchronous
if you read
generator
the
on the
question,
droop control was
what you will
delivering
understand
100
that
megawatt power to the system.
a single
So it
50
is
hertz
generating
synchronous
initially
generator on
100
the
megawatt,
droop control
okay,
was
at a
delivering
50 hertz
100
system,
megawatt
frequency
power
is
to to the system. So it is generating
What
initially
happened that
100 megawatt,
load got
okay, at
increased
a 50
and
hertz system.
generating power
Frequency is
had to
50 hertz.
increase by 10 megawatt. Okay,
What happened that load got
okay, it
increased
means
and
that
generating power
initially it
had to
was
increase
100,
by
now it
10
have to
megawatt.
deliver the
Okay,
110 megawatt. Okay,
okay,
this is
it
a
means
huge
that
amount because 10
initially it was
megawatt is not
100,
a
now
small
it have to
quantity.
deliver
It
the
is a huge.
110 megawatt.
So
Okay,
at
this is
that
a huge
then
amount
at that
because
point
10 megawatt is not
resulting
a small quantity.
frequency
It is a
dropped to
huge.
49.75.
So
Okay, so
at that
further
point,
increase in load in the
resulting
system resulted in
frequency dropped to
frequency to
49.75.
49.25.
Okay.
Suppose you want to
So
increase
further
further,
increase in
you
load in
drop
the
to the
system resulted in
49.25.
frequency to
So at this
49.25.
condition, the
Suppose you
power
want
in
to increase
megawatts
further,
supplied by the
this dropped to
generator.
the
So if this
49.25.
power, this
So
steam,
at this
if
condition, the
steam
power
turbine
in
is there,
megawatt
so
supplies by
steam
the
should increase
generator.
so that
So
you meet this
this
extra power
power,
demand.
this
Okay.
steam,
So what
if
happens
steam
that
turbine is
frequency
there,
was
so
50.
steam should
Okay.
increase so that
So
you
what
meet
I
this
have
extra power
said that
demand. Okay.
it dropped to
So what happens that
49.75
frequency
if
was
the
50.
100 to
Okay.
110 base
So what I
increase.
have said
So
that
if the
it
further
dropped to
increase amount is
49.75
there,
if the
so it will
100 to
drop to further
110 base increase.
49.25.
So
So this
if the
increase in
further
power have
increased
to supplied
amount is
from
there,
somewhere
so it will
to
drop
meet
to further
to make this
49.25. So
frequency
this increase in power has to
consider
supply
it
from
back to
somewhere
the at a
to
50
meet
hertz cycle.
to make this
So this
frequency
tan
to
theta is
be,
constant that
do
50
consider
minus
it back to the at a 50 hertz
49.75
supply.
divided by 110 minus
So
10.
this tan
Okay.
theta is constant,
And
that
the
50
further
minus
down, if the x amount
49.75
it
divided by
reaches,
110
it is
minus
also
10.
being constant
Okay.
that
And the
49.75
further
minus
down, if the
49.25
x
x
amount
minus 100,
it reaches,
the
it is also
same
being
same tan
constant
theta.
that
Tan theta is means
49.75 minus
delta f
49.25 x
by
minus
delta
100.
p
The
is constant.
same tan
That means
theta.
that
Same theta it
droop
means
constant is constant.
delta
The
f
Kp
by
is
delta
constant. That is
p
Hertz
is
per
constant.
pu
It means
megawatt.
that
Okay.
droop constant is
Megawatt.
constant. There's Kp
So
is
this tan
constant.
theta
That
is
is hertz
constant
per
means delta f by
pu
delta p
mega.
is constant.
Okay.
If you equalize that,
Megawatt.
should be 130.
So this tan theta
Okay.
is constant means
So
delta f
here
by
what
delta p is
I
constant.
wanted to
If you
explain that
equalize that,
if you
x should be
decrease or
130.
increase the
Okay.
frequency, your delta p
So
will
here
change.
what
Delta
I
p
wanted
will
to
change.
explain that
And
if
same
you
concept
decrease
with
or
this,
increase
if
the
your
frequency,
delta
your
f will
delta p
change.
will change.
Delta f will
Delta
change.
p will change.
This delta p will
And
change.
same
If
concept
your
with
delta
this,
v
if
change,
your
then
delta f
q
will
will
change,
change.
delta f
Okay.
will change,
So
this
there is a
delta
two
p will
factors
change.
I've got.
If your
that
delta
Kp,
v change, then
Kp is
delta
equal
q
to
will
delta
change.
f by delta
Okay.
p in
So
negative.
there is a two factors I've
And
got that
Kq.
Kp is equal to delta
v
f by delta p
So
in
there are,
negative,
if you control this
and
Kp and Kq,
kq
you
kq
can
is
control
delta
the
v
P
by
and the
delta
F
q.
and the
So
Q and the
there
V.
are, if you control
Okay.
this kp
So
and
because
kq, you
controllable
can
parameter
control
is
the
what?
p and the f
Frequency,
and the
voltage,
q and the v.
power and the reactive
Okay.
power. How you
So
will
because
control using this
controllable
group concept.
parameter is what?
Okay. This is
Frequency,
the one of the
voltage,
concept
power
for
and the reactive
controlling
power.
this
How you will control
kind of
using
system
this
for
droop control.
increasing when
Okay.
the power increases.
This is the
this
one of
is
the
how
concept
to
for controlling this
make
this
your
kind of
system
system for
back
increasing
in
when
this
the power
frequency of
increases.
the
You
50
should how to
So suppose
make
I say
your
that
system
I
back
my
to this frequency
droop
of the
is
50.
5%. My droop
So
is
suppose
5%.
I say
So
that
what do you mean by
I
this?
my
It means that your
droop
delta
is
f by
5%.
delta p is
My droop is
5%.
5%.
Okay.
So what do you mean
So
by
what do
this?
you mean by
It means
that
that
also?
your delta
It
f by
means that
delta p
your
is
frequency
5%.
is a 5%
Okay.
change. If
So
your
what do you mean by that also?
if there is a
It means
there is
that
a
your
100%
frequency
change
is a
in your power.
5% change. If your
That is the main factor.
if there is
5
a
by 100
there is a
multiplied by
100%
100 is
change in your
5%.
power.
So if your
That
frequency
is the main
changes
factor. No? 5 by 100 multiplied by
and your
100 is
delta
5%.
p changes 100.
So if your
Means that
frequency changes
it changes
5
from 100%.
and
So
your
that means
delta
that
p
5%
changes
droop
100,
is there.
it means that it
So this
changes
will
from
help you solve
100%.
one of the
So
question
that
in the
means that
assignment also.
5%
What is
droop
the meaning of
is
this
there.
500? Okay.
So this will help
Coming
you
to
solve
this
one of the
local
question in the
hierarchical
assignment
control.
also.
What I have
What is the
told you
meaning
that
of this
you have
500?
the local
Okay.
control. Okay.
Coming to this
Above that
local
you have
hierarchical
the
control,
certain
what
other
I have told
control,
you
that
that
is the
you
local
have the
control,
local
secondary
control,
central and
okay.
emergency control.
Above
We will
that you
study
have
this
the
local
certain
control,
other
secondary
control, that is
and
a local
central and
control,
emergency
secondary
control.
control, central and emergency
So
control.
coming to
We
this
will study
local
this local
hierarchical
control,
control.
secondary
Okay.
control and central
So
and
main
emergency
use of this
control.
local
Okay.
control is to control the
So coming to
distributed
this
generator
local
to operate in
hierarchical
the normal
control,
operation.
okay.
Just to normal
So main
operation.
use of this
Okay.
local
There is no
controller is to
fault,
control
there
the
is no
distributed
overcurrent
generator
fault,
to
no
operate in the
overcurrent
normal
fault.
operation, just to
Kind of
normal
system will
operation.
be there.
Okay, there
Why?
is no fault,
Because
there
there
is
is a
no
solar
overcurrent
is
fault,
there.
no
Solar, if you have
overcurrent fault
connected a solar PV
kind of
system
system will be there.
and you are
Why?
not taking
Because
the
there
same
is a
amount of
solar
power
is
to the
there.
load.
Solar, if you
So
connected a
what
solar
way,
PV
where
system
that power will
and
go?
you are
Where
not
this
taking the
voltage
same
generated
amount
will
of
go?
power to the
It will
load.
generate the
So
lot of
what
power
will,
at that
where that
point of
power will
this
go,
capacitor.
where this voltage
Okay, the
generated will go,
voltage will increase at
it will
that point.
generate the
This
lot
will
of power at
generate
the
to over
point of
voltage
this
force.
capacitor. Okay,
Over
the
voltage force.
voltage will
If you are
increase
not
at
taking
that
the
point.
same
This
amount of
will
power, this
generate
will
to
be
over voltage fault.
generated.
over
So
voltage
this
fault
kind of
if you're not
situation,
taking
which
the
is
same amount of
internal to
power
this
which is being
device, this distributed
generated.
generation, it should
So
be
this
avoided
kind of
by
situation which
using
is
this
internal to
local
this
control.
device,
Okay,
this
this
distributed
local
generation,
controller
it
for the
should be
DG get
avoided
operate as
by
a voltage
using
control
this
voltage
local
source
control.
converter,
Okay,
where the
this
voltage
local
reference is
controller for the
provided by the
DG jet
conventional
operate
droop
as a
control.
voltage
But I
control
have told
voltage
you that
source
delta V
converter,
change is
where the
decided
voltage reference is
how much
provided by
delta
the
Q is being
conventional droop
changed.
control. That I
This
have told you
controller
that
feeds the
delta V
current signal
change
in a
is
feed forward
decided
term via the
how much
transfer
delta
function.
Q is being changed.
Why? What is
This
meaning of this
controller
feed
feeds the
forward?
current signal
Let
in a
me tell
feed
you.
forward term via the
Let me
transfer
tell you
function.
by taking that
Why?
example.
What is meaning of this feed forward?
If you
Let me
see
tell you.
this example, okay,
Let me tell you by
not
taking
this
that
example.
example, which I have already
This
told
example,
you.
if you see,
If you
you have
see this
taken the
example,
current as a
okay,
reference from the this
not
grid
this
side. This is
example.
the grid side, and you are
This
taking the
example, if you
current as a
see, you have
reference
taken the
and
current
feeding
as a
forward
reference
to
from this grid
for the
side. This is the
PWM
grid
generation.
side, and you
So
are
this
taking a
is
current
generated
as a
forwarded,
reference and
and then it
feeding
is
forward to this
subtracted for
for the
generating the
PWM
reference.
generation.
So
So
this is
this
the
is
kind of
generated
architecture is
forwarded,
known as the
and
feed
then it is
forward network.
subtracted for
And if you see
generating the
in the
reference.
image also,
So
this is
this
the
is a
current
kind of
feed forward,
architecture is
as
known as
I
the
am
feed
highlighting
forward
what I
network.
am highlighting here.
And if you see in the image also, this is the current feed forward. I am
If you
highlighting
see
what
what
I
I
am
am
highlighting
highlighting with
here.
the yellow color, if you
Let me
see,
take
this is a kind of
the.
system.
If you
Actually,
see
this
what I am
feed
highlighting
forward
with
is
the
there.
yellow
Current
color,
is
if you
taken as
see,
the reference, and what
this is a
what
kind of
voltage
system.
and frequency
Actually,
should be
this
generated,
feed
that
forward
is
is there.
taken from the
Current is
P
taken
and the
as the
Q,
reference, and
and through the voltage
what
control
voltage and
and through
frequency should be
subtractor, this
generated at taken
PWM
from the
control
P
is
and
being
Q,
generated. Okay,
and through
this
the
is a kind
voltage
of
control and through
current feedback,
subtractor,
and this is
this
a
PWM
local
control is
loop
being
of this
generated.
inverter.
Okay,
This is the whole
this
is
is
a
a kind
local
of
loop.
current
So,
feedback,
but
and
there
this
is
is the
a certain drawback.
local loop
Certain
of this
drawback of
inverter.
this droop
This is the
control
whole
is
is
such
the
that
local loop.
a small
So,
mismatch in
but
the
there
grid
is a certain
impedance
drawback. Certain
estimation could
drawback of
result
this
in
droop control is such
inefficient
that
power saving among
a
the droop
small
control
mismatch
users.
in the grid
Suppose you are generating
impedance
P and the Q
estimation
star,
could
and
result in the
from where
inefficient power
you are
sharing
generating
among the
same with
droop
the what
control
is
disease.
demand.
Suppose you are
If there is
generating
a
P
error
and the
in
Q
that,
star,
how
and
you
from
your
where you are
DC should be
generating, you are
operating
generating
in
same
the
with the
same
what is
fashion.
demand. If there is a
Okay,
error in
so there
that, how
to avoid
your
the
disease
internal
should be operate
circulating current,
in the same
so you
fashion.
have to generate the exact
Okay,
amount of this
so there
resources,
to avoid the
and it is
internal
unsuitable
circulating
for the
currents,
non-linear
so you have
and
to
single
generate the
phase
exact
loads,
amount
as the
of these
harmonic current
references,
is also sharing.
and it is
That is
unsuitable for
also
the
one of the point
non-linear
that there is
and single phase
not a
loads as the
fundamental you are
harmonic current is
transferring.
also sharing.
You have a
That
multiple
is
number
also
of
one of the point
plus
that there is
fundamental
a
plus third
not a
harmonic, fifth
fundamental you are
harmonic, seventh
transferring.
harmonic, 11th
You
harmonic,
have a
13th
multiple
harmonic,
number of
lot of harmonics
plus
are there.
fundamental
So
plus
this is
third
not
harmonic,
suitable for
fifth
the
harmonic,
non-linear
seventh
type of
harmonic,
system
11th harmonic, 13th
and
harmonic.
this
Lot
group
of
control,
harmonics are
because
there.
you are taking
So
delta
this
F,
is not
delta P
suitable for
as
the
KP
non-linear
factor
type of
and
system.
KQ factor
And
as
this droop
delta
control,
V
because
by
you are
delta
taking
Q
delta
factor.
F, delta
Okay,
P as
so
KP
you
factor
don't have
and
any
KQ
reference
factor
of
as
this
delta
harmonics
V by
itself,
delta Q
not
factor.
current also.
Okay,
So this kind
so
of
you don't have
droop
any
control is being
reference
avoided,
of this
and also the
harmonics
poor
itself,
frequency
not current
regulation with
also.
the
So
application
this
of the
kind of
reactive power.
droop control is being
So
avoided,
going to this
and
further
also
slide,
the poor
there are
frequency regulation with
certain
the application of
improved
the
droop
reactive power.
control methods are there.
So going to
Based
this
upon
further
that,
slide,
there is a
there
one
are
is virtual
certain
impedance
improved
based
droop
droop
control
control.
methods are there.
Virtual impedance is that,
Based upon that,
suppose you are
there is a
generating a
one
P.
is
P is
virtual
EV
impedance
by
based
X sine
droop
delta
control. Virtual
power.
impedance is that,
What is being generated?
suppose you
The
are
Q
generating
star
a
is
P.
such that
P is
V by
EV by X
E
sine
cos
delta
delta minus V.
power. What
Okay.
is being generated, and the
If you
Q
take
star
this
is such
X
that
as a factor,
V by X
okay,
E
controllable
cos delta
variable,
minus V.
and
Okay.
this P star is
If you
the
take
what
this
the
X as a
reference should be
factor,
generated.
okay,
If you
controllable
control X,
variable,
you can control P
and
star.
this P
And
star
same
is
with
the
that,
what
if you
the
control
reference
X,
should be
you can
generated.
control this
If
P
you
star.
control X,
So
you can control
deliberately,
P star.
if you feed
And
this
same with that,
X,
if you control
suppose
X,
X
you
is the
can control this
combination of
Q star
XL
also.
plus some
So
X
deliberately
reference.
if you
So
feed
if you are
this
generating
X,
a X
suppose X
reference
is the
plus some
combination of
virtual
XL
impedance,
plus some
that's
X
why that's
reference.
from where
So
also you
if
can
you are generating
manipulate
the
this
X
P star and the
reference
Q
through
star.
some
So
virtual
that
impedance,
kind is also
that's why
added
that's
inside
from
of
where also you can
what I am
manipulate
highlighting,
this
if you
P
see
star
there,
and the Q star. So
this
that kind
virtual
is
impedance, if you
also
see
added
this virtual
inside of
impedance,
this.
so
What I am
from where
highlighting,
the
if you
current
see
is
this,
coming, it is
this
being
virtual impedance,
given
if
to
you
this
see
virtual
this virtual
impedance
impedance,
based group
so
control,
from
then
where
the
the
VG
current is
star is
coming,
being generated.
it is being
Okay, so
given
this
to this virtual
performance of the group
impedance
control,
based
this
group
the
control,
microgrid
then the
system, this
VG star
R by
is being
X
generated.
reference are very
Okay,
very important.
so this
Okay,
performance of the group
so
control,
if
this
the
the
viewer
microgrid system, this
grid is
R by X
mostly
reference
go
are
to
very
neutral
very
and
important.
resistive. Okay,
Okay, So
Using a
if the
large
your
inductor between the power
grid is
conductor and
mostly
this
both
AC
inductive and the
bus to make
resistive,
the
okay,
inductive line impedance is one of the
using a large
solution for
inductor between the
increasing this
power
power
conductor
saving with group
and
control.
this AC bus
And the
to make the
simple but
inductive
effective
line
solution is
impedance
that
is one of the
virtually
solution for
emulate this
improving
effect
this
of this
power sharing in the
inductive
group
element in
control.
this link
And the
impedance.
simple but
Okay.
effective solution is
From
that
that also you
virtually
can modify
emulate this
and
effect of
control
this
this P
inductive
star and the
element
Q
in
star.
this
This
link
concept is
impedance.
very
Okay.
this
From
virtual
that also
impedance
you can
is
modify
very simple,
and
and
control
this
this P star and the Q star.
important
This
for this
concept is
parallelized
very
inverters
this
and
virtual
limiting
impedance is
overcurrent under
very
this
simple,
GPU
and this
disturbance. That is the main concept.
important for this
Second
parallelized
concept is that
inverters and
adaptive based
limiting
control. What
overcurrent under
I
the
have
grid
explained in
disturbance.
the
That is the main concept.
fifth number of this
Second concept
tutorial
is
session
that
also,
adaptive
that
based control.
this is
What
adaptive.
I have
Adaptive
explained
means
in
that
the
your certain groups will
fifth
be
number of
adopted
this
based upon
tutorial
that
session
what is
also, that
actual
this
situation
is
is.
adaptive. Adaptive means
These
that your
adaptive groups
certain groups
can be
will be
controlled with the
adopted
certain
based
effects.
upon that what
Suppose
is actual situation
there
is
is a
there.
one concept that
These
manipulative
adaptive
control is one
groups
of the
can be
concept
controlled with the
where
certain
they
effects.
have their
Suppose
prediction horizon.
there is a one
Prediction
concept
horizon is
that
one of the
predictive
thing
control
is
is
there.
one of the
So
concept
you
where they
predict
have
the
their
variable.
prediction
You
horizon.
predict the
Prediction
variable what
horizon is
should be
one
in
of
the
the thing
next
is there.
step. Suppose
So
you are
you
at a IK step
predict the
and
variables.
you
You predict the
at a
variable what
IK
should be
plus
in
K
the
naught
next
second.
step.
So
Suppose
K
you are
naught
at
is
a
the
IK step
future
and you
variable.
predict at
Future
a
variable
IK
from
plus
where
K
you are
naught second.
predicting through
So
this
K
IK.
naught is
Okay.
the
So you have
future
the
variable,
predicted
future
value.
variable from
From
where
that
you are
you should
predicting
predict
through this
and
IK.
put it into
Okay.
this system.
So you
From
have
that
the
you
predicted
should adopt
value.
based upon
From that you should
adopt. This is the
predict
common
and
group
put it
control
into
I am
this
highlighting
system.
with this yellow
From
color
that
if
you should
see.
adopt.
This is
Based
the
upon
common
that
group
it should
control.
adopt.
Okay.
This is the
So
common group
reference
control I am
voltage
highlighting with
producer,
this
if you
yellow
see
color.
this,
If you see,
this
this is
and
the common
in
group
the
control. Okay.
parallelly, in the
So
parallel
reference
fashion, if you
voltage
see
producer,
here,
if you see
this
this
is
and
adaptive group
in
control
the
of the virtual
parallelly
control.
in the
There
parallel
is a
fashion, if you see here,
this virtual
this
is
see there.
generated.
This
This
is
is the
adaptive
Q
to
star
control of
and
the
the
virtual
what the
control.
P is being
There is a
calculated and P and
this
the
virtual is
P and the
generated
Q is
based
calculated.
upon the Q star
So this
and
is
the
the
what
one
the P is
parallel
being
path
Q
is
is
there for
calculated and
this
P and the
adaptive based control.
P and the Q is
So this is the
calculated.
improved based
So this is
method.
the one
So
parallel
coming to
path
this
is there
last type, that
for
is
this
angle group
adaptive
control.
based
In
control.
angle group
So
control,
this
you
is the
measure
improved
delta
based method.
del,
And coming to
del
this
delta.
last type, that is the angle
In
group
del
control.
delta, if you
In
measure
angle group
that
control, you measure the
reference, the
delta L,
secondary
del,
unbalanced control is
del
going
delta.
to this reference
In del
voltage
delta, if
generator
you measure
and is
that
also going
reference,
to
the
this
secondary
this
unbalanced control is
reference
going
voltage
to this
generator and
reference
this
voltage
delta theta
generator
ABC,
and is
which
also going to
generated
this
from this
this
active power
reference
group
voltage
control
generator
inverter
and
2
this delta
and active
theta
power group
ABC,
control through the
which is
inverter 1.
generated
So
from
there are
this
two inverters
active
which are
power group
connected
control
inverter
inverter 2
2.
and active power group
It
control
is
through the inverter
his
1.
PWM
So there are
reference
two
are
inverters
generated
which
to
are connected,
this
inverter 1 and
difference
inverter
also.
2.
If you are connecting two
It is
inverters in
his
the parallel,
PWM
if you
reference are
check whether
generated
this
through
delta
this
del delta,
difference
that is
also.
secondary
If you are
unbalanced
connecting
control is
two
there.
inverters in the
From that
parallel,
you should
you
give
should
the
check whether this
reference, take the
del
reference
delta,
also from
that
the
is
active power
secondary
control
unbalanced control is there.
and then generate
From
the
that you
reference
should give
voltage
the
for
reference,
this
take the
resonant
reference also
control
from the active power
resonant
control
controller inverter
and
or
then
active
generate the
inverter.
reference
Okay.
voltage
For
for
both the
this
inverters.
resonant control,
So coming to this,
resonant controller
this
inverter
angle
for
based group
active
control
damping.
has significantly
For
low
both the
frequency
inverters.
deviation compared
So
to the
coming to
frequency
this
group control.
this angle
And this
based group
phase angle
control has
measurement of the
significantly
voltage
low
in
frequency
ADAC can be
deviation
used for the low
compared to the
bandwidth
frequency
GPS
group
based
control.
communication
And
technique.
this phase
Okay.
angle measurement
This
of the voltage
please remember
VSC
this
can
point, that
use for
this
the
is
low
very important
bandwidth
for the low
GPS based
bandwidth
communication technique.
low
Okay.
bandwidth
This
GPS based
please remember
communication
this
technique.
point that
Okay.
this is very important for
Coming
the
to
low
this
bandwidth
some of the
low
last
bandwidth
topic, that
GPS
is
based
secondary
communication
central
technique.
emergency
Okay.
control. What we
Coming
have
to
already
this
studied.
some of the last
This
topics,
local
that
loop
is the
control,
secondary
second,
central
secondary
emergency
control.
control.
Third is
What
that
we have
secondary
already
or the central
studied.
emergency control.
This
Which
local
these
loop
have
control,
three
second
types,
secondary
two types
control,
mainly.
third is that secondary or the
Distributed
central
and
emergency control.
central control.
These
Central
have
control
it
is such
three
that
types,
all
two
DGs
types
are
mainly,
connected to a central point.
distributed
You have a central
and
controller.
central controller.
From that,
Central
the
controller
reference
is
should be
such
taken
that
out and
all
be taken
DGs
in.
are connected to a a central
and you
point,
if you
you
have
have a central controller.
this distributor
From
generator,
that the
then it
reference would
have
be
a
taken out
self
and taken in. Okay,
decision making
and you
property.
if you have
From here, that it
this
take the
distributor generation, then
decision
it have a
itself that what
self
amount of it should
decision
generate.
making
Okay,
property.
if you
From
see in
there
the
that
right side
it
image
take the
also, there is a
decision
communication channel
itself that what amount of
between
it
this
should
primary
generate.
control is
Okay,
there, between
if
this
you see in the right
DG1,
side image
okay,
also,
which is
there is a
connected to this
communication
micro
channel
MG microgrids.
between this
So you
primary
have a
control is there
multiple primary
between this
controls are there,
DG1,
which is
okay, which is
communicated to the
connected to this
communication
micro
channel,
MG
this
microgrid.
DTFD,
So you have a
and secondary
multiple
control
primary
unit. This
controls are
secondary
there,
control
which is
unit take the
communicated
voltage
through
and
the
the frequency
communication
as a
channel
reference
with a
and
VTFD
generate read
and secondary control unit. This secondary control unit take the
and the FD.
voltage and the
VD is the
frequency
V
as a
star and the
reference
omega
and
star,
generate
and
V
then
V
communicate through the
D,
communication channel
VD
through
and
this
the
family
FD. VD
control.
is the
Okay,
V star and the omega
and
star,
it
and
transport to
then
the convert.
communicate through the
So this
communication
is a
channel
kind of
through this
distributed
primary
generate, because
control.
this
Okay,
microgrid
and
have a
it transport to the
self-generating,
further.
self-decision
So
making
this is a
capacity.
kind of
Okay,
distributed
so
generate,
this is
because
a, there are
this
three types
microgrid
of,
have a
if you see there
self-generating,
are three
self-decision
methods,
making
that is a
property. Okay,
multi-agent based technique,
so this is a,
model
there are
predictive
three
control
types
technique,
of,
and
if you
consensus
see,
based
there
technique.
are three methods, that is a
In the
multi-agent
multi-agent,
based
the
technique,
primary element of the
model predictive control
this
technique, and
multi-agent system is
consensus
based
based
technique
technique.
is an agent which
In
can
the
be physical or
multi-agent, the
virtual
primary element of the
entity
this
situated in an
multi-agent system is
environment
based technique is an
and
agent
capable or
which can be physical or virtually
autonomously reacting
entity
to the changing
situated in
environment.
an
It means
environment
that
and
if there is a
capable or
changing environment, there is a certain
autonomously
entity is there
reacting to the
inside of
changing
that
environment.
environment
It means that
which takes the
if there is a
decision by
change in
self
environment, there
and
is a certain
manipulate the
entity
variable
is there
based upon
inside
that.
of that
And it
environment
has a two
which
or more
takes
agent,
the
not a
decision by
single,
self
two and more
and
agents can
manipulate the
also be
variable
there,
based
with
upon
his
that.
intelligence
And
being
it has a
categorized
two or more agent, not
reaction
a
to the
single,
environment,
two and more
proactive,
agent can also be
the
there,
goal
with its
oriented action
intelligence
or
being
social
categorized, it
ability,
reaction
that
to
is
the
communication
environment,
based ability.
proactive,
Okay,
the
and the
goal
second
oriented action
type is
or
that
social
technique is that model
ability, that is
predictive based
communication
control,
based
where I
ability.
have told you
Okay,
that it
and the
predicts the
second
future,
type is
predicts the
that
future.
technique is that model
Okay,
predictive based
of
control,
the
where I have
certain
told you that
predicted
it
horizon.
predict the future,
So this
predict the
MPC
future.
technique is a
Okay,
futuristic
of
approach
the
where an
certain predicted
optimization problem
horizon.
is solved
So
based
this
upon the demand
MPC
and
technique
generation
is a
forecast. Forecast is very
futuristic
important.
approach where an
It is
optimization
forecasting the
problem
future,
is solved
and the
based upon
prediction
the
of the
demand and
dependent
generation
variable are carried
forecast.
out. It is
Forecasts are very important.
advantageous is
It
solve
is
the
forecasting the
multivariable
future, and
optimization
the
problem
prediction
using
of
a
the
forecast
dependent
method.
variable are carried out.
So
It is
if you have the
advantageous is
multiple
solve the
inputs, suppose you have the
multivariable
V, F,
optimization problem
E and the
using the
Q.
forecast and the
So it
feedback.
take the all the
So
input
if
and
you
manipulate the
have the
variable based
multiple
upon
inputs,
that.
suppose
So
you
it's
have
the
the V,
multi-agent
F,
kind of
E and the
system.
Q. So it
Multivariable
take the
kind of
all the input
optimization
and
problem can be
manipulate the
solved
variable
from that.
based upon that.
And
So
third
it's
is
the
the consensus
multi-agent
based
kind of
control
system.
technique. So
Multivariable
through
kind
the
of
mutual
optimization problem
suppose
can be
there are
solved from
multiple
that.
agents are
And
there,
third is the
through
consensus
mutual
based control
consensus,
technique.
if
So
they
through the
generated
suppose there
one
are
optimal
multiple
point
agents are there,
which is fitted
through
to
mutual
maintain this
consensus, they
P and the
generate a
Q
one
reference.
optimal
Okay,
point. One
so through
optimal point
consensus based
which is
distributed
fitted to
control, the
maintain this
distribution optimization
P
problem
and
is
the Q
solved to arrive
reference.
at a
Okay.
converse
So through
solution
consensus based distributed
for
control,
all
a
DER users.
distribution
Okay,
optimization problem is solved to
and the
arrive at a
second thing is
converse
that
solution
centralized based control.
for
In the
all DER
centralized based
units.
control,
Okay.
if you see what is that,
And the
if you
second
see the
thing is
large
that
figure, you don't
centralized
have
based
any
control. In the
SCUs there.
centralized based control,
Here
if
the
you see
SCUs is
what is
there,
that,
central
if
control
you see
unit
the
is
large
there,
figure,
which is
you
connected
don't
to
have
the
any
all,
SCUs
central
there.
control unit is
Here the
connected to the
SCUs
all
is
DGs.
there,
Okay,
central control unit is there,
this is
which
the
is connected
which
to
is connected to
all,
the main
the
grid.
central
So
control
through
unit
the
is connected to
communication
the all
channel,
DGs.
this
Okay.
common communication channel is
This is the
connected to all
which
the
is connected to the
distributed
main
generation.
grid. So through the
So this is a
communication
kind of
channel,
centralized
this
approach.
common
The
communication channel
problem
is
here in the
connected to
centralized
all the
approach is
distributed
that
generation.
if the
So
communication
this is
fails,
a kind of centralized
communication in
approach.
the one
The
system is
problem
failed,
here in the
then
centralized
this
approach is that
other system
if the
gets
communication
manipulated.
fails,
Okay,
communication in the
if you
one
have a
system is
distributed
fails,
system,
then
then one
this
fails,
other
there is a
system
no
get
effect.
manipulated.
But
Okay.
in this
If you have
centralized
a
approach,
distributed
where one
system,
effect can cause
then
the
one
other
fails,
to
there is a no
come into
effect.
existence, the
Okay.
effect.
But
Okay.
in this centralized approach, the one
Okay.
effect can cause the
So
other
this
to
kind of
come
system
into existence. The effect.
also there.
Okay.
So coming to this
Okay.
this global hierarchy.
So this kind of
because I
system
have told you that you have
also
the
there.
local,
So
you have the
coming to this
secondary, you have
this
emergency,
global
and
hierarchy,
upper level
because
you have a
I have
global
told you that
hierarchy control
you have a
which
local,
control the
you have a
all the
secondary,
disease
you have
and
emergency,
microgrid setups
and
altogether.
upper level you
So
have a
this
global hierarchy
control
control
manages
will
the
control
power
the
flow between
all
this
the disease
given
and microgrid
this
setups at a
main
time.
grid
So this
and
global control
interconnecting
manages the
microgrid,
power
given
flow
main
between this
microgrid and
given
other interconnecting
this
microgrid and the
main
main
grid and
and you also have the
interconnecting
global
microgrid,
control
given
receive
main
power references
microgrid
from
and
the
other
distribution
interconnecting
management
microgrid
system,
and the main grid.
because you have a
And you also have the global
distribution
control
management
receive
system
power
also.
references from
Suppose
the distribution
you
management
suppose
system,
the,
because you have a distributor
UP
distribution management
example,
system
Uttar
also.
Pradesh example,
Suppose
they have the
suppose
UP
the
PCL.
I'll
So
take
through
this
UPPCL, your
UP example,
this is the
Uttar Pradesh
discom,
example,
and
side
this
that they
discom
have the
gives the power
UPPCL
to
is there.
your home.
So through
And
UPPCL,
charge
your
for that.
this is
And
the
this
discom, and
distribution
this
management
discom
system,
gives the
the
power power to your
also have
homes
a certain reference
and
of this
charge
power,
for that.
because how much power
And
is
this
being
distribution management
given to this
system, the DMS, also have a certain reference of this power, because
this
how much power is
distribution
being
network. Okay,
given
so
to
this
this
reference is also taken from this
you
DMS
to
system
this
to
this
process the error
distribution
between
network.
this
Okay,
actual and the
so
reference
this
value. So
reference is
this is the
also taken from
advantages
this
that
DMS
global
system
hierarchical control
to
is that
process the
it
error
takes the
between this
reference
actual and
from
the
the
reference value. So this is
management
the
system only,
advantages that global
and
hierarchical
it
control is there.
facilitates
It
the
takes the
economically
reference
optimal
from the
operation,
distributive
and it takes
management
the
system
slowest
also,
control in the hierarchy,
and
because
it
it takes a lot of time
facilitates the
for the
economically
computation, because
optimal
it is a
operation,
upper
and
level
it
of
is
the
the
hierarchy.
slowest control in the hierarchy, because it
And
takes a
also
lot of
error
time
should
for
be
the
less at the
computation,
upper
because it
level.
is a
So
upper
for that
level
it
of the
also take
hierarchy,
time, and it is a centralized
and the
control.
also
And
error should be
this
less
level is
at the
working with
upper
the
level.
distributed
So for that is
network
also
in the
take time, and it is a
outside of this
centralized
MES.
control,
Okay,
and
microgrid.
this level is working with the
Coming to
distributed
this
neural
last
network
topic,
and the
of this today's
outside
session,
of
that
this MGs.
intelligent control.
Okay,
What kind
microgrid.
of intelligent control technique
Coming to
can be
this
evaluated?
last topic of this
You
today's
have one
session,
kind of
that
control is such
intelligent
that
control.
this is
What
the
kind of
proportional
intelligent
controller
control
and this
technique can
decaying
be
controller
evaluated?
or PID based controller.
You have one kind
This is
of controller is
a
such
kind
that
of
this
says
is a
that
proportional
this
controller
is
and
the
the integral
KP,
controller or
KI by
PID
S
based controller.
and plus KDS.
This is
Okay,
the
kind of
kind of
system.
says that
And you have
this
to
is the
put
KP,
certain KP
KI
KID
by
value.
S and
So
plus
suppose
KDS.
this
Okay,
is the
kind of system.
I'm reference
And you have
generating.
to put
This
certain
taking
KP
ID
KID
reference ID
value.
star,
So
and this ID
suppose
is the
this
actual.
is the I'm
So what
reference
it is
generating.
generating, suppose
This
the
taking
ID
ID
star minus
reference ID
ID,
star,
you
and
have
this
to
ID is the
minimize this
actual.
reference. For
So
that you
what
need
it is
certain
generating,
controller.
suppose
Suppose
the
I am
ID
taking
star
PI
minus
controller
ID,
for
you have to
error
minimize
minimization.
this reference.
So
For that
this
you
PI
need certain
controller
controller. Suppose I am
KP
taking
value
PI
needs
controller
to be adopted
for error
based upon this
minimization.
environment.
So this
So you
PI
have a
controller
certain other controller
KP
also.
value
Suppose the
needs
fuzzy
to be
controller,
adopted
adaptive
based
neural
upon this
network.
environment.
This is the
So you have
genetic
a certain
algorithm
other
based system,
controller also.
PSO,
Suppose the fuzzy
adaptive
controller,
neurofuzzy
adaptive
system,
neural
ANFI
network.
system, and a
This is the
multi-agent based
and
controller.
genetic
Yeah,
algorithm
currently
based
we
system
also have
PSO,
certain
adaptive
this
neurophagy system,
decision
NFS
making
system,
tree,
and a
decision tree,
multi-agent based controller.
ML based
Currently, we
algorithms
also
also
have
there. So
certain
kind of
this
multiple
decision
algorithms
making
are
tree, decision
currently
tree,
being
ML
put
based
forward, and
algorithms
seen
also
that
there. So kind of
what is the
multiple
optimally
algorithms are
things
currently
can be
being put forward
get
and
from that.
seen that
Okay,
what
so
is
this
the
is a
optimally
also a
things can
major
be
areas also.
get
Suppose
from that.
in one of
Okay,
my work also I
so
have
this is
not taken
also
this
a
PI based
major
controller.
areas
I have
also.
taken this more
Suppose
MPC based
in
controller,
one of my work
which is
also
a
I have
prediction
taken
horizon
not
based
taken this PI based
predicted
controller.
based
I have taken this more
system
MPC
is
based
also there.
controller,
So based
which
upon
is a
that,
prediction
you
horizon
also can
based
prepare that
predicted
also.
based
So
system is
this is a
also there.
kind of
So based upon that,
issues with
you
this
also can
system, so that
prepare that
you need
also.
to adopt with
So
the
this is a
current
kind of
changes in the environment.
issues with
Okay.
this system, so that
So that's all
you
for
need
the
to
today's
adopt
lecture, and
with
let's
the current
recall that
changing
what
in the
we have
environment.
studied
Okay.
today.
So
Coming
that's all
from
for
the
the
first
today's
topic,
lecture,
that
and let's
importance of the
recall
DG,
that what we have
this
studied
is
today.
distribution system.
Coming
Then
from
we
the
move
first topic,
forward to
that
this skin
importance of
effect.
the disease,
Skin effect, that
this is distribution
what is the
system.
skin effect,
Then
what
we
kind
move
of
forward to this
from
skin
where
effect.
it is a
Skin
prominent,
effect, that
and how the
what
frequency
is the skin
changes,
effect,
then
what
how
kind
it
of
should adopt
from
to
where
that.
it is a prominent,
And this is
and
we
how the
also studied the
frequency
DC
changes,
microgrid
then how
topology,
it
also
should
single bus topology,
adopt to
multi
that.
bus topology,
And this is
and also
we also studied the DC
reconfigurable
microgrid
topology, that is
topologies,
radial and
also single bus
multi-terminal.
topology, multi-bus
And we
topology,
also
and
studied
also
this
reconfigurable topology, that is
this
radial and the
classical and bidirectional
multi-terminal.
DC converter
And we
topology.
also studied
And we
this
solved one numerical also based upon
this
D
classical and bidirectional
computation.
DC converter
And we also
topology,
studied the challenge
and we
in the
solved
DC
one
microgrid.
numerical also based
Then
upon
we
D
have seen that
computation.
what kind of
And
HVDC
we also
projects are
studied
there
the
in
challenge
India
in the
currently
DC
and what
microgrid.
have been completed.
Then we have
Or
seen
we
that the
also
what
studied
kind of
the
HVDC
AC
projects
microgrid
are there in
operation
India
mode,
currently,
then
and what
identic modes,
have been
then
completed.
the control architecture.
Or we also studied
Then
the
also we
AC microgrid
studied this
operation modes, and then
kind of
islanding
system, that
modes,
classification
then
of
the
the power
control
converter in
architecture.
the AC microgrid.
Then also
This is
we
most
studied
important,
this
which
kind of
you
system,
must
that
revise
classification
for
of the power converter
checking
in the
that
AC
what is
microgrid.
actually
This
what
is
is
the most
happening.
important, which
And we
you
also
must
studied
revise
this
for
LCL type grid connected
checking that
inverter,
what is the actually what is
and
being
where I have
happening.
shown you this alpha
And
beta
we also
frame and
studied
the
this
DQ
LCL
frame, how
type
this
grid connected
control
inverter.
architecture is there.
and where I have
Then
shown
we
you this
studied the
alpha
grid
beta
feeding,
frame and the
then
DQ
grid
frame, how
feeding
this
with the
control
passive generation system,
architecture is there.
then we studied grid
Then we
feeding
study the
strategies
grid
with PQ
feeding,
mode,
then grid
then we
feeding
studied
with the
grid
passive
forming,
generation
then
system,
grid
then
supporting,
we study grid
then
feeding
we also
strategy
study
with
the
the
house
PQ
and water
mode,
control in the
then we
islanding mode
study
is
grid
happening.
forming, then grid
and we
supporting,
study this
then
ancillary
we also
services
study the how
from
the
that,
inverter control in
and
the
this higher
islanding
care
mode is
control,
happening,
that is the first is the
and we study
central
this ancillary
this local higher
services
care
from that,
control,
and
and
this
there's
higher
some
care control,
improved
that is
droop
the
methods
first is
also,
the
that is virtual
central
impedance based,
this local higher
adaptive
care
droop
control,
based method, and
and there's
angle
some
droop based
improved
method.
droop methods
And we
also, that
also
is virtual
study this
impedance based,
secondary and the central
adaptive droop
emergency
based
control
method, and
distribution
angle
type,
droop based
and
method.
we study
And we
the
also
two types,
study
that is
this
centralized
secondary and
and
the central
decentralized.
emergency
Okay,
control distribution
and
type,
we also study
and
the global
we
higher
study
care
the
control.
two type, that
Okay,
is centralized
and
and
this intelligent
decentralized.
control
Okay,
technique. Okay,
and we also study
so
the
that's all
global
for
higher
the
care
today's
control.
lecture,
Okay,
and I hope that
and this
I have cleared
intelligent
some of the
control technique.
doubts
Okay,
from
so
your side.
that's all for the
So
today's
thank
lecture,
you so much. If
and
you
I
have
hope
any
that
doubt,
I
you
have
can
cleared
ask me
some of
right
the
now.
doubts
Otherwise,
from
I'll stop this.
your side. So
If you have any
thank
doubt,
you
you
so
can
much.
open
If you
your
have
mic and
any
ask me.
doubt, you can ask me right now.
We will upload this
Otherwise,
slides on
I'll
uh,
stop this.
this Excel sheet what I have been provided.
You can open your mic and
If you have
ask
any
me.
doubt, you can ask me.
We will upload this
Okay, then
slides on
fine.
this
I'm stopping this session.
Excel sheet.
Okay, thank you so much,
If
guys.
you have any doubt, you can